Night has fallen over an ancient landscape. Overhead, the sky is a deep velvet, sprinkled with countless stars that shimmer softly in the darkness. There is a quiet stillness in the air, broken only by the gentle rustling of the wind across the open plain. Under this vast celestial canopy, one can't help but feel a profound sense of wonder and peace. Each point of light above is a star, distant and seemingly eternal, keeping silent watch over the world below. For thousands of years, human beings have gathered under nights like this, gazing up in awe at the heavens. Long before cities and electric lights, the night sky was a brilliant, sprawling map of light. Our ancestors looked up from their fires and humble dwellings, and the stars greeted them as familiar friends. They traced patterns among the stars, figures of gods, heroes, and animals, and crafted elaborate myths to give meaning to the twinkling lights. Different cultures often connected the same dots in their own ways. For example, many peoples saw in the winter sky a mighty hunter, the constellation we call Orion, and nearby a tight cluster of stars, the Pleiades, that some said were 7 sisters eternally pursued by the hunter. Another group of stars might be seen as a great bear slowly circling the pole, or a dragon, or a ship. In this way, the night sky became like a grand storybook written in light, its tales teaching and comforting those beneath. Imagine a traveller in ancient times, lying on the deck of a voyaging canoe in the Pacific, or resting beside a desert caravan's dwindling fire. Above, the stars are the only guide. There is no compass, no modern map, only the night sky. Yet the traveller does not feel lost. Certain stars rise and set in reliable rhythms, revealing the directions and the passing of hours. The band of the Milky Way, a pale luminous river of stars, arches from horizon to horizon. By its glow, and by knowing which constellations lead which, explorers learn to find their way. In that vast, dark dome, the North Star, for those in the Northern Hemisphere, remains steady in the north, providing a celestial north arrow when all earthly landmarks are gone. By watching the sky night after night, year after year, our ancestors learned to mark time by the stars. The return of certain constellations, or the first appearance of a particularly bright star at a specific time of year, would signal a change of seasons, or the time to plant and harvest. The ancient Egyptians, for example, watched for the rising of the star Sirius just before sunrise, an event that foretold the flooding of the Nile and the start of a new year. Out here, far from any human settlement, the sky is crowded with stars. There are so many that even the darkest parts of the sky glow faintly with their collective light. In the silence of a clear night, you can almost feel the ancientness of the starlight. Some of the pinpoints we observe might no longer even exist as they were when that light set out. A few could have perished in spectacular supernova explosions, their brilliance long extinguished, yet their final rays are only now reaching Earth. Other stars will outlast everything we know, continuing to shine for billions of years to come. The sky is a living map of deep time, a reminder of how small a fragment of the cosmic story our individual lives are. And yet, here we are, conscious and curious, able to witness this grand timeline written in light. Under these ancient stars, every human who ever lived has pondered the same lights. The pharaohs of old, the philosophers of Greece, the navigators of Polynesia, the travellers on the Silk Road, all stood under this canopy and felt the same tremor of amazement. The stars visible to the unaided eye are mostly within a few thousand light years of us, relatively local in our Milky Way galaxy. But stretch your imagination further, beyond the faint band of the Milky Way, farther than human eyes can see unaided, lie countless more stars and even other galaxies. Their combined glow is what makes the darkness of the night sky not truly black, but softly lit in places. On especially dark, clear nights, far from towns or fires, that ghostly band of the Milky Way reveals itself as the light of billions of distant suns. Ancient peoples wondered what this delicate band could be. Some called it the backbone of night, others a celestial river, others the spilled milk of a goddess. They had no way to know it was our galaxy seen from within, a disk of stars so vast that it takes light, moving at 186,000 miles each second, over 100,000 years to traverse it.
Beneath such a sky, one cannot help but ask the timeless questions. How far do these stars go? What is our place among them? Over the centuries, we learned that Earth is not the centre of all things, but rather a small world orbiting one star among uncountable others. Long before science proved this, there was already a humbling intuition one could feel on a clear night, a sense that above us looms a vastness beyond comprehension, and that we are part of something far greater than ourselves. The stars also quietly tell us a story about where we come from. It turns out that we have a profound connection to them, one that our distant ancestors could scarcely have imagined. The stars are not just distant lanterns. They are the furnaces in which the universe forges heavier elements. In their hot, dense cores, simple atoms like hydrogen fuse into heavier ones, releasing the light that we see across space. And in the final, glorious deaths of massive stars, in supernova explosions, those newly formed elements are cast out into space, seeding the galaxies with the building blocks of new stars, new planets, and eventually, life. All the gold on Earth, all the iron in your blood, the calcium in your bones, the oxygen we breathe. These elements were fashioned in the bellies of ancient stars billions of years ago and scattered across the cosmos when those stars died. Think about that for a moment under this starry sky. The very matter that makes up our bodies, that makes up everything and everyone we hold dear, was forged long ago in stars that lived and died before our sun was born. We are truly made of stardust. In a literal sense, the stars are our ancestors. When we gaze up at the night sky, we are looking into a kind of ancestral home. The light that comforts us in the darkness is a souvenir of those stars, a gentle reminder that we are connected to the cosmos in the most intimate way. That realization brings a comforting feeling of kinship, as though the universe itself has given birth to us, and we carry a piece of its history within us. The night deepens, and the earth turns slowly, causing the stars to glide from east to west. Time seems to slow down out here. Hours pass quietly, marked only by the subtle rotation of the starry dome overhead. Perhaps a meteor streaks silently across the sky, a tiny grain of cosmic dust sacrificing itself in a brief flare of light as it meets the atmosphere. It's a fleeting gift of brightness, reminding us that even in stillness, the cosmos is in motion. The darkness around us might feel immense, but it is not empty. It is filled with the silent presence of all those distant suns and worlds, each a beacon in the great dark sea of space. Under ancient stars like these, wrapped in the nocturnal hush, it's easy to imagine stories and possibilities. Perhaps, on a planet circling one of those distant stars, there are other beings looking up at their night sky, wondering as we do. The universe is old and vast, and the stars above have seen ages come and go. They shone on a world of towering dinosaurs long before humans existed, on our distant ancestors whispering around simple fires, and now on us in this present moment. We share the night with the ghosts of the past and the promise of the future. As the stars gently wheel overhead, we feel a sense of continuity and belonging across time. Here on Earth, on this gentle night, we lie under ancient stars, feeling a quiet pull of curiosity and yearning. We know that morning will come soon enough, and the sun's light will wash away this starry tapestry. But for now, in these precious hours of darkness, we can savor the cosmic vista. We can close our eyes and still feel the presence of the glittering heavens above, trusting that they will be there when we open them again. The stars invite us to dream, to explore, not only with our minds, but with our hearts. They encourage us to venture beyond the horizon of the known, even if for now it is only in our imagination. From these reveries beneath the stellar canopy, one truth emerges softly. We do not stand apart from the universe. We are deeply a part of it, born from its very elements and sustained by its energy. The story of the stars is our story too. In the grand timeline of the cosmos, stars were born, lived brilliantly, and died. From their remnants, new stars and planets emerged. Around one such new star, a collection of planets took shape. And on one of those planets, our Earth, life found a foothold under the light of those ancient stars and grew in complexity. Now, a form of that life has become aware and is able to look back up at the sky to ponder its origin. As we continue our journey, we turn our attention to that special planet, our home in the cosmos, which coalesced from the dust of ancient stars and carries their legacy within it. Our journey now brings us to that special blue world, our home, gently circling a star in a quiet corner of the galaxy. From the silence of space, Earth appears as a luminous blue marble set against the black canvas of the cosmos. Swirls of white clouds trace across its surface, and broad stretches of deep blue ocean and rich green-brown land make it uniquely vibrant. The polar regions gleam with bright caps of ice, and around the planet's edge, a thin blue haze marks the glow of the atmosphere, our fragile veil of air. This is our haven in the vast universe, the only place we know that cradles life. It may seem small from afar, but up close, Earth is a world brimming with wonders, alive with continents and seas, forests and deserts, all part of a living tapestry. How did this oasis come to be? In the youth of the solar system, about 4.5 billion years ago, our planet was born out of chaos. It began as tiny grains of dust and rock within a swirling disk of material encircling the newborn sun. These pieces clumped together under gravity, colliding and merging in a violent dance of creation. Gradually, a primitive Earth took shape, a glowing, red-hot sphere of molten rock. In those early days, our infant planet was an inhospitable place, its surface an ocean of magma, constantly pummeled by asteroids and comets that rained down from the unsettled solar system. Each impact shook the young world, gouging out craters and adding intense heat. But some of those impacting bodies also delivered water and other ingredients that would one day be vital for life. As time went on, Earth began to cool and calm. A solid crust formed over the molten interior, like a skin hardening on hot lava. Volcanoes still pierced this crust, releasing steam and gases from deep within the young Earth. Dark clouds gathered in the thick sky, and for the first time, rain began to fall on the cooling rocks below. It rained and rained, perhaps for thousands of years, warm water pouring from murky skies. Lightning flashed and thunder boomed over a barren world as the water pooled into low-lying areas. These basins became the first oceans. The once glowing face of Earth was transformed. The fiery surface was quenched in many places by endless rain, and the planet's exterior turned dark and wet. Vast seas now glittered under a clearing sky, and an atmosphere began to take shape, blanketing the planet in a mixture of gases. The air of this young world was very different from what we breathe now, thick with carbon dioxide, methane, ammonia, and water vapour, but scarcely any oxygen. Under those alien skies, in warm, primordial seas, and around undersea hot springs, something miraculous was brewing. The spark of life. Perhaps in sunlit, shallow pools along new coastlines, or around mineral-rich hydrothermal vents on the ocean floor, the first simple organisms emerged. They were microscopic and humble, nothing more than tiny single cells, but they had the entire planet to themselves. Over millions of years, these early life forms diversified. Some learned to harness the sun's energy through photosynthesis, using sunlight to turn carbon dioxide and water into food, and releasing oxygen as a waste product. Slowly, over an immense span of time, this changed everything. The oceans accumulated oxygen, and it began to trickle into the atmosphere. Gradually, the murky skies cleared and turned blue. With oxygen in the air, new possibilities opened up for life. The stage was set for an explosion of diversity in the seas and eventually on the land. Life flourished. In the planet's vast oceans, tiny microbes evolved into more complex forms, and soon the waters teemed with strange creatures. Multitudes of marine animals swam in those ancient seas, and plants, and then animals, eventually ventured onto land, greening the continents and populating the swamps and forests. Forests of towering ferns once spread across the land. Later, great conifer forests and flowering plants appeared. In time, dinosaurs, some as large as houses, roamed Earth's warm plains and jungles, ruling for millions of years. Earth's face changed continuously through these ages. Continents slowly drifted around the globe, sometimes gathering into supercontinents, only to break apart again. Mountains rose and wore away. Great ice ages came and went, and now and then calamity struck. A massive volcano eruption or an asteroid impact that caused widespread extinctions. Yet life proved remarkably resilient. Even after the great catastrophe that ended the age of dinosaurs, life persisted and rebounded, filling the world with new creatures, including, eventually, our mammalian ancestors and countless other forms. The tapestry of life was torn at times, but never destroyed. It kept reweaving itself, painting Earth with ever-changing forms and colours. Only in the most recent blink of cosmic time did humans enter this unfolding story. We stand on a planet almost unimaginably old, and yet our own presence on it is so very young. For hundreds of thousands of years, our ancestors lived and wandered across the face of Earth, intimately connected to nature and beholden to the sky above. They learned the patterns of the land and the seasons under those stars. But the Earth itself was their entire universe. It is only within the last few moments of that long history, only in the past few decades, that we have gained the ability to slip the bonds of Earth's gravity and truly behold our home from afar. In doing so, we came to see Earth in its full glory, as a single, beautiful sphere floating in the void, and we began to grasp our place in the cosmos with new humility and wonder. Imagine, for a moment, standing on the moon's silent grey surface and looking up at the sky. There, rising above the horizon of barren rock, is Earth. It appears as a brilliant blue and white orb hanging in the blackness, a delicate marble glowing with reflected sunlight. From that vantage point, Earth is both breathtaking and small. An astronaut on the moon could cover our planet with a thumb held at arm's length. Yet behind that thumb would be everything. Every ocean and continent, every cloud, every city, every person who has ever lived. Astronauts who gazed back at Earth from the moon have described a profound sense of awe and unity. They saw no borders, no divisions, just one shining world, lonely and beautiful, surrounded by infinite darkness. That distant view of Earth, often called Earthrise, after the famous photograph, changed our perspective forever, showing us plainly that we all share one fragile world.
Back on Earth's surface, under the familiar blue sky, life proceeds under the warmth of the sun and the gentle glow of the moon. We mark time by the turning of Earth. Day comes as our part of the world faces the sun's light, and night falls as we turn away into darkness. Each day, the sunrise paints the sky in gold and pink, and each sunset fades it through orange and purple into the dark of night. And as Earth travels around the sun each year, the tilt of our planet's axis brings the cycle of seasons. Spring arrives with blossoms and renewed warmth. Summer follows with long golden days. Autumn brings crisp air and leaves of red and gold. And winter wraps the world in quiet and rest. These patterns, day and night, the waxing and waning of the seasons, have been the heartbeat of our world for as long as life has existed. They arise from celestial motions, Earth's rotation, and its path around the sun. Yet to us, they are the intimate, familiar rhythms of life, guiding planting and harvest, hibernation and migration, wakefulness and sleep.
Our moon has been an integral part of Earth's story from the beginning. The prevailing theory is that the moon formed from a titanic collision early in Earth's history. A Mars-sized body struck the young Earth, and the debris coalesced into our moon. Ever since, the moon has been a constant companion in our sky. Its presence has helped stabilize Earth's tilt over geologic time, preventing extreme climate swings. The moon's gravitational pull tugs on our oceans, drawing them into the rhythmic rise and fall of tides. These tides may have nurtured life's first hesitant steps onto land and still guide the cycles of many coastal creatures. For humans, the moon has been a source of wonder and a keeper of time. Its changing phases served as a natural calendar, and its gentle light has guided travellers and inspired myth, art, and science. Over millions of years, the moon's interaction with Earth has even slowed Earth's rotation slightly, making our days longer than they were in the distant past. In these ways, our moon has quietly shaped the evolution of life and the rhythms of our planet, all while enchanting those who gaze at its silver glow.
Earth is not only fortunate in its placement, it also comes equipped with defences that make our world hospitable. Deep within the planet, the churning of liquid metal in Earth's outer core generates a magnetic field that extends far into space. This magnetic field forms a protective shield, the magnetosphere, which deflects many of the charged particles continuously streaming from the sun. Without it, the solar wind might gradually strip away our atmosphere, as it has done on Mars. Thanks to our magnetic shield and our thick atmosphere, life on Earth's surface is largely spared from high-energy radiation. Occasionally, when the sun is particularly active, waves of charged solar particles crash into our magnetosphere. Some of these particles spiral down along Earth's magnetic field lines toward the poles and collide with molecules high in the atmosphere, causing the sky to glow. The result is the aurora, the northern and southern lights, ethereal curtains of green, red, and violet light that dance against the starry background near the poles. For those lucky enough to witness them, the auroras are a gentle reminder of our planet's invisible guardians and our connection to the sun's restless energy. In so many ways, Earth resides in a cosmic sweet spot. It's at just the right distance from the sun for our days to be warm enough for liquid water to persist on the surface, but not so close that our world is scorched. Any nearer to the sun and Earth might have become a baking desert. Any farther, and it might be an icy wasteland. This comfortable placement is often called the Goldilocks zone. Not too hot, not too cold, but just right for life. Our atmosphere, enriched by life over eons, provides air to breathe and helps regulate temperature, while also protecting us from meteors and harmful radiation. And thanks to Earth's particular journey and its companions, from the stabilizing tug of the moon to the shielding embrace of the magnetic field, life has been able to flourish here for billions of years through calm times and catastrophes alike. Life on Earth is amazingly diverse and tenacious, flourishing in environments as different as deep-sea hydrothermal vents, arid deserts, and polar ice. Yet, as far as we know, in all the vastness of the universe, Earth is unique in harbouring such an abundance of life. Scientists have detected thousands of planets around other stars, and some may be somewhat like Earth, but we have yet to find clear evidence of life elsewhere.
It's possible that living creatures exist on some distant world, orbiting a far-off sun, but if so, they have remained silent to us so far. For now, this blue planet is a solitary garden oasis amid a cosmos of barren rocks and gas giants and glowing stars. That makes our home all the more precious. It reminds us that life is a rare and delicate phenomenon. When we look up at the night sky or send probes to other planets, part of what we're doing is seeking kinship, searching for something that mirrors the living Earth. But until we find it, Earth stands alone as the cradle of life. It is our beautiful and fragile home. For us, Earth is more than a planet. It is the ground beneath our feet and the sky above our heads, the giver of our food and water, the stage for every moment of our lives. All our joys and sorrows, every story ever told, have unfolded on that pale blue dot. It is small and delicate, but it is irreplaceable. Yet, even as Earth is special, it is not alone. It is one member of a larger family, the solar system, bound together by the gravity of the Sun. Our planet shares space with 7 other major planets, from scorched Mercury to distant Neptune, each following its path around our common star. There are also dozens of moons and countless smaller bodies, like dwarf planets, asteroids, and comets. A whole community of worlds travelling through space alongside Earth. At the centre of it all is the Sun, our sustaining star, pouring out the light and warmth that make life possible on our world. To understand the context of our home and how it fits into the broader scheme, we must turn to that centre. We journey now to the Sun itself, Sol, the brilliant heart of our cosmic neighbourhood, the life-giving star that dawns in our sky each day. At the heart of our cosmic neighbourhood blazes the star that makes all life on Earth possible, the Sun. In the daytime sky, its brilliance is overwhelming. It outshines every other star, turning the heavens a bright blue and banishing all but the closest moon. We feel the Sun's warmth on our skin and see its radiance bring the world to life with colour each day. The Sun is our steadfast companion, rising every morning and setting every evening, a cycle so fundamental that it marks the passage of time for us. Since time immemorial, this life-giving star has been a source of wonder, reverence, and inspiration. Many ancient peoples personified the Sun as a deity or hero. They built temples to honor its rising and monuments to mark its highest and lowest points in the sky. Indeed, across cultures, the Sun was often revered as a powerful god or goddess travelling the heavens. People celebrated the Sun's return at dawn and held rituals to beckon its return in times of eclipse. Stone circles like Stonehenge were aligned to sunrise on the longest and shortest days. Great temples in Egypt were dedicated to Ra, the sun god, greeting each dawn. In the Americas, Asia, and elsewhere, solstice festivals and elaborate ceremonies honoured the sun's life-giving cycle. These monuments and myths all speak to a fundamental truth. The sun's light and warmth are essential. Without the sun, our world would be a frozen, dark, lifeless rock adrift in space. Everything we depend on, the air we breathe, the water we drink, the food we eat, ultimately is fueled by the sun's energy. Every sunrise and sunset, every change of season, every growth of a green leaf testifies to the sun's influence. Like all stars, the sun had a beginning. Before there was a sun or an earth, there was a giant cloud of gas and dust in this region of the galaxy. This cloud, enriched by the ashes of older stars that had lived and died, drifted for ages until something disturbed it. Perhaps the shockwave from a distant supernova, or perhaps it simply reached a critical density under its own gravity. The cloud began to contract, and as it did, it spun faster and flattened into a disk, much like a whirlpool or a spinning skater pulling in their arms. Most of the material collected at the centre. As the pressure and temperature climbed higher and higher in that core, a critical point was reached about 4.6 billion years ago. Hydrogen atoms began to fuse into helium, and a new star blazed to life. Our sun was born, a second-generation star in a galaxy already old. It burst into radiance, and the fierce solar wind from the newborn sun blew away much of the remaining gas in the inner part of the disk. What was left behind in the sun's vicinity coalesced into the planets, moons, asteroids, and comets. In time, one of those newborn planets would become the Earth, orbiting its parent star in a stable, life-friendly zone. But in those first moments, there was only the sun, shining brilliantly amidst the dissipating fog of its birth cloud. The sun that emerged is a colossal sphere of hot plasma, essentially a continuous nuclear explosion contained by gravity. It is hard to grasp just how large and massive the sun is. Over 1 million Earths could fit inside it, and it contains 99.8% of all the mass in the solar system. This immense mass produces a powerful gravitational pull that anchors all the planets in their orbits. Deep in the sun's core, conditions are extreme, around 15 million degrees Celsius and crushing pressure. There, hydrogen nuclei fuse into helium in a process called nuclear fusion. Fusion releases an enormous amount of energy, which is the source of the sun's light and heat. Each second, the sun converts roughly 600 million tons of hydrogen into helium. The energy produced by those reactions struggles outward, bouncing around through the sun's dense interior for a very long time. In fact, a photon of energy may take tens of thousands of years to work its way from the core to the sun's surface. Only then can it escape into space as sunlight. Thus, the sunshine that warms your face on a clear afternoon is energy from the sun's heart. Energy that was made, perhaps, before human civilization began, now completing a long journey across space to reach you. Some of that sunlight spreads across approximately 93 million miles of space to Earth. Even at light speed, it takes light about 8 minutes to make the journey from Sun to Earth. That means when you see the sun in the sky, you are looking at it as it was roughly 8 minutes ago. In that brief span, light has raced across the void to bring warmth and illumination to our world. Every sunrise is like a gentle reunion, the sun's rays arriving after travelling through the darkness of space to bathe our planet once more. The sunlight that filters through green leaves, sparkles on the waves of the sea, or falls softly on your shoulders, is a direct connection between our world and its star. It is the lifeline that ties us to the sun's immense energy output. If we could safely look closer at the sun, using special filters or dedicated telescopes, we would see that its surface is far from tranquil. The bright face of the sun, called the photosphere, is like a boiling ocean of luminous gas. Up close, it has a mottled texture, like a grainy honeycomb. These are enormous convection cells, each about the size of a continent, where hot plasma rises from the sun's interior and cooler plasma sinks back down. Scattered across this roiling surface, we might notice some darker spots. These are sunspots, slightly cooler regions, though still extremely hot, that look dark by contrast against the hotter background. Sunspots can be larger than the Earth and often appear in groups. They come and go over days or weeks, and their frequency waxes and wanes in an approximately 11-year cycle, tied to the sun's magnetic heartbeat. Along with spots, the sun sometimes displays graceful prominences, giant loops and arches of glowing plasma that extend from its surface into space, following the curving lines of the sun's magnetic field. These fiery ribbons can linger for days, towering high above the sun's limb, and when seen against the darkness of space, they form a beautiful, delicate corona around the sun's edge. Occasionally, the magnetic forces that hold these prominences become unstable and erupt. When that happens, or when twisted magnetic fields around sunspots suddenly snap and realign, the sun launches bursts of energy and particles outward. Intense flashes of light called solar flares and huge billowing clouds of charged particles called coronal mass ejections are hurled into the solar system. If one of these eruptions is directed toward Earth, we may feel minor effects. Our satellites, radios, or power grids might experience disruptions, but more often we simply enjoy a lovely side effect, an intensified aurora, those shimmering lights in the polar skies. These gentle displays remind us of the sun's occasional tempests. Still, for all these dramatics, the sun's behavior is usually steady enough to nurture life without interruption. It is a dependable, life-giving beacon that only occasionally reminds us of its power through a burst of solar weather. Beyond the sun's bright surface lies its ethereal outer atmosphere, the corona. We normally can't see the corona because the sun's disk is so dazzling, but during a total solar eclipse, when the moon completely covers the sun for a few minutes, the corona becomes visible as a pearly white halo extending far into space. Intriguingly, the corona is much hotter than the sun's surface below, a mystery that solar scientists are still working to understand. From this superheated halo, a constant stream of charged particles flows outward in all directions. The solar wind. The solar wind is like the sun's breath, a faint gust of particles, mostly electrons and protons, that travels throughout the solar system.
It takes a few days for these particles to reach Earth. The solar wind shapes the tails of comets, making them always point away from the sun, and it carves out a vast bubble in the galaxy around us, the heliosphere, within which all our planets reside. Far beyond Pluto's orbit, the solar wind finally grows thin and weak, and pressures from the interstellar medium push back. There, at the boundary called the heliopause, the sun's influence gives way to the space between the stars. In a sense, the sun's atmosphere stretches out to touch all the planets and defines the very boundary of our solar neighbourhood. One of the sun's most important qualities, from our perspective, is its stability. Our sun is a middle-aged star, roughly 4.5 billion years old, and it has been shining with a steady brightness for a very long time. It will continue to burn in a stable manner for about another 5 billion years. This constancy has provided Earth with a relatively unchanging environment in which life could develop and thrive. Not all stars are so accommodating. Some massive stars burn their fuel quickly and end their lives in cataclysmic explosions after only a few million years. Some smaller stars are prone to violent flares that could be devastating to close-by planets. By contrast, our sun is just the right size and temperament for life as we know it. It is not the largest star, nor the most luminous. In fact, it's quite ordinary as stars go. But for us, it is perfect. A calm, steady source of light and warmth. Generation after generation, the sun has risen and set reliably, and it will continue to do so far beyond the span of human civilization, a reassuring constant in an ever-changing world. Virtually every facet of life on Earth is intertwined with the sun's energy. Green plants, from the tiniest algae to the tallest trees, capture sunlight and use it to manufacture food through photosynthesis, forming the base of the food web and ultimately nourishing every animal, including us. When you eat a piece of fruit or a slice of bread, you are consuming stored sunlight that a plant captured. Sunlight also drives Earth's winds and weather. The sun's heat lifts water from the oceans into the sky as vapor, which later falls as rain and snow, filling rivers and lakes, watering crops and shaping the landscape. Sometimes
when sunlight breaks through rain clouds just so, it paints a rainbow across the sky, a gentle reminder of the sun's hidden colours revealed by the falling raindrops. Even the gentle breezes that stir the trees and the mighty jet streams high in the atmosphere are powered by solar warmth, creating differences in air pressure. The sun's energy evaporates water that later falls as precipitation, sustaining the water cycle that all life depends on. Even ancient energy reserves like coal and oil are essentially sunlight captured by plants and plankton millions of years ago and stored beneath Earth's surface. In a profound sense, the sun's energy runs through all living things and fuels almost every natural process on our planet. We carry sunlight in our bodies, in the warmth of our blood, and the energy that moves our muscles. For the calories we burn are essentially the sun's energy, processed through the food we eat. Life on Earth is truly an ongoing conversation with the sun, a continuous exchange of light and energy back and forth.
It is little wonder, then, that the sun holds a special place in human hearts and cultures. Each day, its rising is like the rebirth of the world, and its setting a gentle closure. At dawn, as the eastern sky begins to glow, and those first rays peek over the horizon, the world transforms. Darkness yields to light, colours return, birds sing, and creatures stir. There is a profound sense of renewal, of hope, as a new day begins. At dusk, as the sun sinks low, the sky is often painted with glorious hues of orange, pink, and purple. The light softens, the heat of the day ebbs, and a calm falls over the earth, preparing for rest. For millennia, people have watched these daily transitions in awe. They have inspired prayers, poems, and quiet contemplation. Sunrise promises that light and life carry on. Sunset reassures us that night is a time of rest, not fear, and that the sun will come again. The dependable return of the sun after each night has comforted humanity through all our history, reminding us that even after darkness, light finds a way. The sun may be an ordinary star in a vast universe, but to us it is uniquely important. It is the star that gives us life, that anchors our days and our sense of time. It connects our small world to the wider cosmos with every warm beam. In its light, we see our world, and by its grace, we thrive. Orbiting this magnificent star is a whole family of worlds. 8 major planets circle the sun, each with its own character and story. They are our neighbours in space, the wandering points of light that ancient sky watchers noticed moving differently from the fixed stars. Closest to the sun is tiny,
broiling Mercury, then radiant, cloud-covered Venus, then our own Earth and its companion moon, then rusty Mars. Further out, past a wide gap filled with asteroids, come the gas giants, mighty Jupiter and elegant ringed Saturn, and farther still, the ice giants, Uranus, tipped on its side, and deep blue, windy Neptune. Along with these planets orbit a plethora of moons, and countless smaller bodies, dwarf planets like remote Pluto and Eris, icy comets that occasionally pay us a visit, and rocky asteroids that mostly keep to themselves. All of them are bound to the sun by invisible threads of gravity, just as Earth is. Having come to know our star, we now embark on a voyage outward to visit these other worlds, the diverse companions that share our solar journey around the sun.
The first stop on our outward journey is Mercury, the innermost planet. Mercury is a small, rocky globe, not much larger than Earth's moon, and in many ways it looks similar to the moon, a grey, heavily cratered surface bearing the scars of countless ancient impacts. Mercury circles the sun swiftly, completing an orbit in just 88 Earth days, living up to its name as the fleet-footed messenger of the gods. Daytime on Mercury is blistering hot, enough to melt lead because it is so close to the sun. The sun looms more than 3 times larger in Mercury's sky than it does from Earth. Yet Mercury has virtually no atmosphere to hold on to the heat, so when night falls, and a single Mercury day-night cycle lasts a very long time, the temperature plummets to far below freezing. It's a world of extremes, searing days and frigid nights in a stark, airless silence. If you stood on Mercury at noon, the sky would be black and filled with stars, even as the sun blazed overhead, because without an atmosphere, there is nothing to scatter sunlight and make the sky blue. You would feel the sun's fierce heat on the side facing the sun, while your other side radiated heat away into the cold of space. Mercury is a harsh, barren little world that has baked and frozen in the sun's glare for billions of years, quietly orbiting in solitude. Next, veiled in brilliant clouds, comes Venus. Venus is often called Earth's twin because it is similar to Earth in size and gravity. But in truth, it is a very different world. If Earth is a paradise for life, Venus is more like an inferno. It is wrapped in a dense, choking atmosphere of carbon dioxide that is over 90 times heavier than Earth's air at the surface. Opaque clouds of sulfuric acid perpetually hide its surface from view. These clouds reflect sunlight well, making Venus shine brightly in our sky as the morning star or evening star. But beneath them lies a realm of extreme heat and pressure. Sunlight struggles to penetrate the thick cloud cover, creating a perpetual, murky daytime gloom on the surface. That surface is incredibly hostile. The air pressure is about 90 times greater than Earth's at sea level,
equivalent to being about 900 meters deep in an ocean on Earth. And the temperature is around 465 degrees over 860 degrees, hot enough to melt lead. In fact, Venus is even hotter than Mercury, despite being farther from the Sun, because its thick CO2 atmosphere has caused a runaway greenhouse effect, trapping heat relentlessly. Venus rotates very slowly and in the opposite direction of most planets, meaning that on Venus, the Sun would appear to rise in the west and set in the east, if one could see it through the clouds. A single day-night cycle on Venus lasts longer than an entire Venusian year. The planet's surface, mapped by radar through the clouds, is a volcanic landscape of rolling plains, highland plateaus, and thousands of volcanoes, some of which might still be faintly active today. No human eyes have ever seen a Venusian sunrise, or the surface directly without mediation by instruments. We have, however, sent probes. The Soviet Venera landers in the 1970s and 80s survived only minutes in the crushing pressure and heat, but they sent back images of a desolate, dimly lit, rocky plain under a sulphurous sky. If you could stand on Venus with an impossible heat-proof suit, you would be enveloped in a dense, yellowish haze. The landscape would be lit in dull orange hues. You'd feel an immense pressure around you, and the air would be utterly unbreathable. There would be an uncanny silence. The thick air doesn't carry sound well, and the wind is minimal at the surface. It's a world where water cannot exist, and even rocks can glow faintly from the heat. And yet, from afar, Venus appears, serene and beautiful, shrouded in white. It serves as a cautionary tale that a planet almost the same as Earth in size can follow a very different path. Venus, the brilliant star of dawn and dusk, hides a hellish environment beneath its lovely clouds. Beyond Earth's orbit lies Mars, the fourth planet from the Sun. Mars has long captured human imagination with its reddish appearance in the night sky. The ancient Romans named it after their god of war, seeing in its blood-red colour an omen of fire and conflict. Today we know Mars as a smaller, colder cousin of Earth, a world of rust and rock. Its surface is a dry, frigid desert covered in red dust and littered with boulders. Mars's atmosphere is extremely thin, about 1% the density of Earth's, and composed mostly of carbon dioxide. It offers almost no insulation or protection, so heat from the sun's daylight quickly escapes into space at night. By day, the Martian sky is a butterscotch or yellowish colour, tinted by fine dust suspended in the air. By evening, it can turn a muted blue-grey near the setting sun, the reverse of Earth's pattern, because of the way Martian dust scatters light. Mars's landscape is marked by colossal features. There are enormous volcanoes, like Olympus Mons, which towers nearly 14 miles high, about 3 times taller than Mount Everest, and is the largest volcano in the solar system. There is also a titanic canyon system, Valles Marineris, that stretches a fifth of the way around the planet, as if a giant hand once gouged a deep scar across Mars's middle. The ground is iron-rich, giving Mars its rusty hue, and its surface is covered in craters, giant extinct volcanoes, and rocky plains, telling of a once active world now largely fallen silent. Long ago, Mars was more geologically active and possibly much wetter. We see dry riverbeds, delta-like formations, and minerals on Mars that suggest water once flowed on its surface, perhaps running through valleys and gathering in lakes, or even an ocean in the distant past. If we could travel billions of years back in time, we might find a Mars with blue rivers winding through a reddish landscape, and maybe a vast northern ocean. Today, nearly all of Mars's water is locked up as ice in the polar caps, which are made of both water ice and frozen carbon dioxide, or hidden as permafrost in the soil. Mars now seems to be a world asleep, cold, quiet, and still. Its thin air and weak sunlight make it barren and harsh. Sometimes, though, Mars's winds stir to life. They can lift the ubiquitous dust into vast storms that engulf the entire planet, turning the sky opaque for weeks. But eventually, the dust settles, revealing again a stark, frozen desert. Despite its seemingly inhospitable state, Mars remains profoundly intriguing. It's a world that had the ingredients for life long ago, and perhaps, in some niches underground, might still harbour simple life, even now. At night on Mars, the sky would be black and filled with stars, much like on Earth, though the sun, seen from Mars, is only about 2/3 the size it appears from Earth. Daytime on Mars is bright, but the sun's light is weaker. It feels like late afternoon, even at noon. Mars has 2 tiny moons, Phobos and Deimos, which are likely captured asteroids. They are irregularly shaped and cratered, looking more like potatoes than our spherical moon. Phobos, the closer one, zips around Mars so fast, orbiting in about 8 hours, that it rises in the west and sets in the east, twice each Martian day, appearing as a fast-moving shadow if you were on the surface. Deimos, smaller and farther, moves more slowly. Standing on Mars, the landscape around you would at once feel alien and oddly familiar. Rocky red sands, distant hills, and a horizon not so different from a desert on Earth, except under a butterscotch sky. At sunset, you might see the sky turn a brief blue near the sun, and watch Phobos creep across the twilight sky like a swift ghost. Mars beckons to us as the next step in exploration. Someday humans may walk on its surface, crunching the rusty sand beneath their boots, aware that they stand on another world under the light of a foreign sun. Between Mars and Jupiter lies a vast region of space, populated not by a single world, but by countless small ones. The asteroid belt. Here, countless chunks of rock and metal, the leftover building blocks that never became a planet, orbit the sun in a broad band. They range in size from tiny pebbles to dwarf planet-sized Ceres, which is about 600 miles across. Despite what science fiction might depict, these asteroids are so far apart that a spacecraft can fly through the belt and likely never encounter one. Space in the belt is overwhelmingly empty, with each asteroid separated from its neighbours by millions of miles. They silently circle the Sun, as they have for billions of years, largely unchanged, like a cosmic museum exhibit, preserving the solar system's youth. Occasionally, two asteroids may collide, shattering into fragments, or a gravitational nudge from Jupiter might send a small asteroid drifting inward toward the Sun. Some of those fragments have fallen to Earth as meteorites, giving us tiny hands-on samples of that ancient era. By and large, though, the asteroid belt is a quiet realm, a wide and diffuse ring of rocks tracing the Sun's waste, whispering stories of the time when planets were still forming. Beyond the asteroid belt, the king of planets awaits, Jupiter. Jupiter, named for the king of the ancient Roman gods, is a gas giant of immense size and mass. More than 1,000 Earths could fit inside it, and it outweighs all the other planets combined. Unlike the small rocky worlds of the inner solar system, Jupiter is composed mostly of hydrogen and helium. It's akin to a star that never ignited. Through a telescope, Jupiter appears as a banded sphere, striped with broad bands and zones of cloud in shades of white, yellow, tan, and reddish-brown. These stripes are high-speed winds jetting through Jupiter's atmosphere in opposite directions, where ammonia clouds form the lighter-coloured zones and other chemicals produce the darker belts. One feature stands out prominently: the Great Red Spot, a vast storm roughly twice the width of Earth that has been raging like a hurricane for at least 300 years. Jupiter rotates very quickly, completing a full spin in just about 10 hours, compared to Earth's 24 hours, which causes its clouds to whip around the planet and flattens Jupiter slightly at the poles. There is no solid surface on Jupiter. If you tried to descend, you would transition from gaseous atmosphere to thicker without a clear boundary, eventually reaching crushing pressures and temperatures that would destroy any craft long before finding a core. What we see of Jupiter is its upper atmosphere, a magnificent, ever-changing tapestry of swirling clouds, spots, and storms. Lightning flashes have been observed in those clouds, and Jupiter's poles glow with auroras hundreds of times more powerful than Earth's, fueled by its intense magnetic field. Jupiter is not only a planet, it is like a miniature solar system in its own right. It has nearly 80 known moons. 4 of these, the Galilean moons, are especially large and intriguing, each one a unique world. Io, the closest to Jupiter, is a tortured moon of fire and sulfur. Its surface is mottled yellow and orange from sulfurous deposits, and it is the most volcanically active body in the solar system. Volcanoes on Io constantly erupt, sending plumes hundreds of miles high and painting its surface with fresh lava. Next is Europa, slightly smaller than our moon, a smooth, bright white ice world. Europa's surface is crisscrossed by long cracks and lines. It's relatively free of craters, indicating that the surface ice is continually renewed. Beneath Europa's icy crust lies a global ocean of liquid water, kept liquid by heat from tidal flexing, as Europa is gravitationally pulled by Jupiter. This hidden ocean, potentially twice the volume of all Earth's oceans combined, makes Europa one of the most promising places in the solar system to search for extraterrestrial life. Further out orbits Ganymede, the largest moon in the solar system, even bigger than the planet Mercury. Ganymede has a mix of very old, dark, cratered regions and somewhat younger, lighter regions marked with grooves, indicating some past geological activity. Ganymede is unique among moons in having its own magnetic field, likely generated by a liquid iron core. And then there's Callisto, the farthest of the four, about the size of Mercury as well. Callisto's surface is extremely ancient and heavily cratered. It looks like a cosmic icebox full of dents. It is thought to have changed little since the early days of the solar system. If you could stand on Europa's frozen surface, you would see Jupiter looming enormous in the sky, banded and beautiful. Perhaps you'd witness Io as a bright, star-like point racing across Jupiter's face, or see the shadow of Ganymede as a small dark dot traversing the clouds of Jupiter below. This dynamic dance has enchanted those who observe it ever since Galileo first pointed a telescope at Jupiter in 1610 and realized those moons were orbiting Jupiter. Evidence that not everything in the heavens revolved around Earth. Jupiter's massive presence has helped shape our solar system. Its gravity shepherds swarms of asteroids and comets, and it may have acted as a shield, drawing in some objects that might otherwise have struck the inner planets. With its swirling multicolored clouds and its retinue of moons, Jupiter stands as a colossus in the night sky, the first of the outer giants, and truly one of the solar system's great wonders.
Continuing outward, we arrive at Saturn, the second largest planet, and perhaps the most elegant. Saturn is adorned with a magnificent system of rings that sets it apart from all other planets. Even a small backyard telescope reveals this beautiful feature. Broad, thin rings encircling a honey-gold planet. These rings are made up of countless particles of ice with a bit of rock, each orbiting Saturn like a tiny moon. They span over 170,000 miles from one end to the other, yet in many places they may be only tens of yards thick. If you were close to Saturn, you'd see the rings resolved into bands and gaps, structures created by the gravitational influence of Saturn's moons and by resonances within the ring particles themselves. From afar, the rings appear solid and gleaming. Up close, they are a vast, flat expanse of floating ice chunks, ranging in size from grains to boulders, each reflecting sunlight. Saturn itself, like Jupiter, is a gas giant, mostly made of hydrogen and helium. It is a bit more than half as large as Jupiter, and about 1/3 its mass, making it much less dense. In fact, Saturn would float in water if there were an ocean large enough, because it's less dense than water. Saturn's atmosphere is somewhat more muted in colour than Jupiter's, with bands of pale gold, butterscotch, and grey. It has fierce winds, and periodically will exhibit a great white storm that encircles the planet. Saturn spins rapidly. A day lasts about 10.7 hours, causing it to bulge at the equator. When you gaze at Saturn, whether in an image or through a telescope eyepiece, it almost seems too perfect to be real. A golden globe suspended in the darkness, surrounded by its ethereal rings. Saturn is accompanied by a great number of moons, more than 80 known at present. Each moon is a world of its own, and together they form a sort of miniature solar system around Saturn. The largest, Titan, is especially remarkable. Titan is bigger than the planet Mercury and is the second largest moon in our solar system. It's wrapped in a thick atmosphere rich in nitrogen, like Earth's, but with a dense orange smog of complex hydrocarbons. This atmosphere hides Titan's surface from view, but we've learned a lot from spacecraft. Titan has rivers, lakes, and seas, not of water, which would be frozen solid in Titan's frigid temperature of 290 degrees F, but of liquid methane and ethane. It even has methane rain and weather. In many ways, Titan is like a strange, colder cousin of Earth, where methane plays the role that water does here. Next, there's Enceladus, a much smaller moon, only about 300 miles across, but one that has captured imaginations. Enceladus has a bright, shiny surface of fresh ice, making it one of the most reflective bodies in the solar system. It also has geysers, enormous plumes of water vapour and ice crystals that erupt from cracks near its south pole, feeding material into Saturn's E-ring. These geysers indicate a subsurface ocean of liquid water beneath Enceladus's ice shell, kept warm by tidal flexing. Enceladus, like Europa, is considered a prime candidate in the search for life beyond Earth, as its interior ocean could harbour hydrothermal vents and chemistry suitable for microbes. Saturn has many other moons as well. Icy Rhea, Dione, and Tethys, battered by craters. Iapetus, with one side as dark as coal and the other as bright as snow. Little moonlets like Pan and Atlas that orbit within the rings themselves, carving gaps. If you could float just above Saturn's rings, you would witness an almost surreal vista. Below you, the enormous striped planet slowly turning. Around you, the vast, flat rings stretching outward, shimmering as they catch the sunlight. And beyond, the pinpricks of Saturn's moons moving along their own orbits. On Saturn's night side,
You might see the rings as a dim band lit by the sun on the opposite side, and Titan as a smudgy orange dot drifting among them. It is a scene of cosmic tranquility and grandeur, one of the most breathtaking in our solar system.
Venturing farther out, we come to Uranus, the seventh planet from the Sun. Uranus is an ice giant, a cousin to Jupiter and Saturn, in that it's mostly hydrogen and helium gas surrounding a dense icy core, but it's smaller and has a greater proportion of water, ammonia, and methane ices inside. To our eyes, Uranus is a calm blue-green orb. The lovely tint comes from methane gas in its upper atmosphere, absorbing the red component of sunlight and leaving a cyan glow. Through most telescopes, Uranus appears as a small, featureless disk, and for a long time it was thought to be quite boring weather-wise. But spacecraft and modern observations have found that Uranus does have faint cloud bands and occasional storms, though they're subdued compared to Jupiter or Neptune. What makes Uranus truly peculiar is its tilt. Uranus rotates on its side. Its axis is tilted by about 98 degrees relative to its orbit. It's as if at some point in its history it was knocked over. Perhaps a colossal collision early on sent it sprawling. This extreme tilt means that as Uranus orbits the Sun, taking 84 Earth years for one trip, each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. During its long summer, one pole points sunward and basks in unending daylight, while the other pole is in a prolonged winter night. As Uranus moves along its orbit, the poles gradually trade places in receiving sunlight. For an observer on Uranus, seasons last decades and come with extreme changes in the sun's path in the sky. Uranus has a faint system of rings and at least 27 known moons. The rings are narrow and dark, discovered only in the late 20th century, when scientists watched a star blink out as Uranus's rings passed in front of it. The moons of Uranus are mostly icy and small. Uniquely, they are named after characters from literature, Shakespeare and Pope, rather than classical mythology. One moon, Miranda, stands out for its bizarre appearance. It looks as though it was shattered and clumsily put back together. Miranda's surface has giant cliffs. One is 12 miles high, chevron-like grooves, and mismatched regions of young and old terrain, suggesting a violent past. If you were on Miranda's surface, low gravity would make for a slow, floating hop with each step, and in the sky you'd see Uranus, a huge greenish sphere covering much of the sky, with rings edge-on and barely visible. From Uranus's distance, about 1.8 billion miles from the Sun itself is just a very bright star, providing dim daylight, about 1/400th of the light we get on Earth. The environment out there is incredibly cold, around 350 degrees. Uranus quietly rolls along in the dim outer reaches, bearing its extreme tilt and faint rings, a pale blue dot in our night telescopes, and a strange sideways world up close. Finally, at the edge of the planetary lineup, we reach Neptune,
the eighth and outermost major planet. Neptune, named after the Roman god of the sea, is an ice giant like Uranus, but a more intense, deeper blue in colour. It's similar in size to Uranus, slightly smaller in diameter, but a bit more massive. The vivid azure hue comes from methane in the atmosphere, and perhaps some other trace components. Despite being so far from the Sun, about 30 times farther than Earth, Neptune's atmosphere is surprisingly active. It boasts the fastest winds in the solar system, with jet streams that can reach over 200 miles per hour. When Voyager 2 flew by Neptune in 1989, it spotted a dark storm about the size of Earth raging in Neptune's southern hemisphere. They called it the Great Dark Spot, analogous to Jupiter's red spot. That particular storm later vanished. When the Hubble telescope looked in the 1990s, it was gone. But other dark spots have appeared since, showing that Neptune's weather changes over time. Neptune also has bright, wispy white clouds that can be seen casting shadows on the lower cloud layers. These are thought to be methane ice clouds riding high in the atmosphere, even with the feeble sunlight it receives. The sun is just a tiny distant glow. Neptune has a dynamic climate with seasons and storms. Through the seasons, each last over 40 years. Neptune is encircled by a system of thin, faint rings and has 14 known moons. The largest moon, Triton, is one of the most intriguing moons in the solar system. Triton orbits Neptune in the opposite direction to Neptune's rotation, a retrograde orbit, suggesting Triton was likely captured by Neptune's gravity long ago, rather than forming alongside it. Triton is extremely cold, around 335 degrees. Its surface is a mix of frozen nitrogen, water ice and other ices, giving it a bright, reflective, pinkish-white complexion. Voyager 2 observed geysers on Triton, dark, nitrogen gas plumes erupting from its surface, lofting particles that then fall back as a smudgy coating. This indicates that despite Triton's deep freeze, there is some internal warmth and active geology. Perhaps tidal heating from its capture, or radioactive heating in its core. Triton has a very thin atmosphere as well, just a faint haze. If you stood on Triton, well insulated of course, you'd find yourself on a silent, frozen plain. The sun would be a tiny, distant star, giving a faint daylight. In the sky, Neptune might appear as a large bluish disk, partially obscured by distance and any thin haze. You might witness a dim Neptune set on the horizon, tinging the icy ground blue for a brief moment. Neptune itself takes a whopping 165 Earth years to complete one orbit around the Sun. Since it was discovered in 1846, it has only completed one full circuit in 2011. Out here, nearly 4.5 billion kilometers from the Sun, the environment is quiet and dim. The Sun is just a pinpoint of light. Neptune, with its windy blue atmosphere and its moon Triton orbiting against the grain, marks the end of the line for the classical planets, a beautiful, remote sentinel at the frontier of our star's domain. But even here, we have not yet left the Sun's influence. Beyond Neptune lie the outermost reaches of the solar system, a realm of icy fragments and distant minor planets that form a tenuous bridge between our planetary neighbourhood and the emptiness beyond. It is to these distant borderlands that we now venture. Now, with Neptune behind us, we peer into a realm of deep space, where the sun's influence grows faint, but does not vanish entirely. Out here, the darkness is nearly complete, and the sun has dwindled to a brilliant star-like point in the black sky. Yet even in this cold outer expanse, a few last wayfarers still orbit our sun. One of them is Pluto, once counted as the 9th planet, now understood to be one of many dwarf planets in the distant Kuiper belt. Pluto, named after the Roman god of the underworld, a fitting moniker for such a far, shadowy world, travels on a tilted, elongated orbit that carries it billions of miles from the sun, sometimes even farther out than Neptune. At its farthest, it takes light more than 5 hours to reach Pluto. For most of its long year, 248 Earth years, Pluto receives only a dim twilight from the sun. For a long time, Pluto was merely a speck of light in our telescopes, mysterious and undefined. But in 2015, a robotic spacecraft finally flew past this little world, revealing it to be surprisingly complex and beautiful. Pluto, we discovered, has icy mountains soaring as high as the Rockies on Earth, and vast, flat plains of frozen nitrogen with curious polygonal cell patterns. It even has a thin blue-tinged atmosphere that appears at sunrise and sunset, a delicate halo of haze around its frigid surface. One of the most striking features seen is a big, heart-shaped bright region on Pluto, a vast plain of nitrogen ice, informally called Tombor Regio, as if Pluto wears a pale heart on its sleeve. Pluto also has a large moon, Charon, so big relative to Pluto that the two of them orbit a point in space between them, like a dumbbell. They are sometimes referred to as a double dwarf planet. Charon's surface is more uniformly grey, covered in craters and canyons. At its north pole lies a reddish cap of material that may have escaped from Pluto's atmosphere and fallen onto Charon. Pluto and Charon are locked in mutual rotation, forever showing the same face to one another as they dance around their common centre of gravity. In addition to Charon, Pluto has a handful of much smaller moons, tiny irregular chunks of ice with names like Styx, Nix, Kerberos, and Hydra, little companions circling the Pluto-Charon pair. If you stood on Pluto, you might see Charon looming huge in the dark sky, not rising or setting, but hanging at one spot, if you're on the correct side of Pluto, while the sun itself would be a distant, blindingly bright pinpoint, providing a faint daylight about as bright as twilight on Earth. Pluto is not alone in its distant abode. It's part of a vast collection of icy bodies known as the Kuiper belt, a broad ring of frozen remnants left from the solar system's formation. Out in the Kuiper belt roam other dwarf planets like Eris, Makemake, and Haumea, along with countless smaller icy fragments. They are ancient, primordial pieces, orbiting slowly in the frigid twilight at the edge of the sun's domain. Every so often, gravitational nudges send one of these distant objects on a journey toward the inner solar system. When that happens, we on Earth witness a visitor from the outer darkness, a comet. These icy wanderers, as they draw closer to the sun, begin to warm and release gas and dust. They grow fuzzy comas, glowing heads, and often unfurl long, luminous tails that can stretch millions of miles. From Earth, a bright comet is a breathtaking spectacle, a luminous brushstroke across the night sky, reminding us that our solar system extends far beyond the familiar planets. One famous example is Halley's Comet, which returns to our skies about every 76 years. It has been observed since antiquity, each time astonishing those who look up before it sails back into the depths of space. Each comet's visit is a reminder of the connection between our world and the farthest reaches of the sun's influence. New discoveries in this far region are still being made. In just the last few decades, astronomers have found several dwarf planets out here, and some suspect there might even be a yet undetected large planet lurking in the darkness, subtly influencing the orbits of these distant bodies. Whether or not this Planet 9 exists, the speculation serves as a reminder that even in our own solar system, mysteries remain, and there are places we have yet to fully explore. Many comets hail from an even more distant reservoir than the Kuiper Belt, from a hypothetical spherical swarm of icy bodies called the Oort cloud. The Oort cloud is thought to be a vast shell surrounding the solar system, a halo of trillions of cometary nuclei extending perhaps a quarter of the way to the nearest stars. These frozen wanderers are usually far too distant and faint to detect, but occasionally one is dislodged by a passing star or galactic tide, and begins the long fall toward the sun, arriving perhaps millions of years later as a long-period comet, one that might grace our skies once and never be seen again in a human lifetime. The existence of the Oort cloud is inferred from the paths of comets that come from all directions, as if from the random depths of space, rather than along the flat plane of the planets. If the Kuiper Belt is a disk, the Oort cloud is a vast sphere, marking the outer boundary of the Sun's family. If we could view our solar system from high above, we'd see the tiny inner planets close to the Sun, the giant planets farther out, the glittering ring of the Kuiper Belt beyond them, and then a great, dark emptiness, sparsely populated with frozen nuclei, the far-flung Oort cloud, reaching out to interstellar space.
It is at this far frontier that humanity's most intrepid messengers are now venturing. In 1977, we launched 2 spacecraft, Voyager 1 and Voyager 2, on a grand tour of the outer planets. After visiting Jupiter, Saturn, and for Voyager 2, also Uranus and Neptune, these explorers kept going, coasting outward with no destination except away. Voyager 1 was the first to break through into what scientists call interstellar space, the region between the stars, in August 2012, when it passed beyond the heliopause, the outer boundary of the Sun's
magnetic influence. Voyager 2, following a different trajectory, entered interstellar space in 2018. Today, both Voyagers are over 14 billion miles from Earth and still sending back faint signals. Each carries a golden record with sounds and images of Earth, a friendly greeting cast into the cosmic ocean, destined to wander the galaxy for ages. On these records are recorded greetings in dozens of human languages, a broad sampling of music from different cultures, and natural sounds like wind, rain, thunder, birds, and whales. A portrait of our world intended for any finder, be it alien intelligence or far future humans. They are humanity's emissaries to the deep unknown, sailing silently on an endless voyage. They will continue drifting long after their instruments go silent, perhaps to be discovered one distant day by other beings, or perhaps only as enduring monuments to our species' desire to reach out across the void. How far the Voyagers have gone, and yet how much farther the nearest stars lie. The closest star system to our own, Alpha Centauri, is more than 4 light-years away. That's about 25 trillion miles. At Voyager's speed, it would take over 70,000 years to reach it. These gulfs between the stars are almost unfathomable. Interstellar space seems nearly empty, a vast, silent expanse of nothingness. And yet, even this emptiness is not truly empty. It holds tenuous wisps of gas and dust, stray atoms drifting for eons, and the faint threads of distant starlight crossing the darkness. We find ourselves now at the very edge of the sun's realm, a threshold between our familiar neighborhood and the wider galaxy. Behind us, the sun's domain grows faint. All the planets, moons, and comets that orbit our star now lie far behind, mere specks swallowed by the darkness. When Voyager 1 looked back from this distant vantage in 1990, at about 4 billion miles away, it captured a poignant image of Earth against the vastness of space. In that photograph, now famous as the pale blue dot, our planet appears as a tiny bluish speck caught in a scattered ray of sunlight. In that single point of light was everything we know, every ocean and continent, every building and tree, every life, every love, every conflict, every story ever told. Seeing our world reduced to that delicate dot is profoundly humbling. It reminds us that in the grand stage of the cosmos, our home is exceedingly small and fragile, and yet, for us, it is supremely important. Now, ahead of us, lies the infinite sea of stars. The Milky Way, which from Earth was a misty band across the night, now unfurls all around as a glorious sweep of countless lights. Our Sun is one among hundreds of billions of stars in this galaxy. From here in interstellar space, we are immersed in that vast starry congregation, We are truly adrift in the interstellar ocean, with the cosmic night stretching boundlessly before us. And so here we are, drifting in the starlight of the interstellar sea, feeling both the profound solitude of the void and a stirring connection to everything around us. The silence out here is deep, yet not empty. It is filled with the faint whispers of distant stars. Every one of those stars is a sun like ours, perhaps with its own family of planets. Our Milky Way galaxy contains hundreds of billions of such stars, an almost unfathomable multitude. Our journey from the warm cradle of our home world to the chill of these outer reaches shows us both how special our tiny oasis is and how vast the universe beyond truly is. As we pause at this frontier, it's awe-inspiring to reflect on the immense distance we've travelled and the far greater distances that still lie ahead. We have come so far, yet in the grand scheme of the cosmos, we have only just stepped off the shoreline and into the shallow waters of a much larger cosmic ocean. And the desire to go farther, to know what lies beyond, is deeply human. It is the same spirit that sent our ancestors walking across unknown lands and sailing into uncharted waters with only the stars to guide them. Now those distant stars themselves beckon us onward in a cosmic voyage. In this quiet pause at the edge of starlight, we linger and reflect, allowing the enormity of what lies beyond to settle in our minds. The next steps may take us farther than ever, but we feel ready. The journey is by no means over. With wonder and curiosity lighting the way, we will continue onward, venturing deeper into the universe, toward the galactic wonders that await in the next chapter of our voyage. Out beyond the borders of all that is familiar, we drift deeper into the cosmic darkness. The last rays of our distant sun have faded from view. In their place, countless new stars emerge around us, shimmering gently against a backdrop of endless night. They are everywhere we look, above, below, to every side, as though we are submerged in an infinite sea of stars. It is a serene and silent ocean of light, stretching out in every direction, each star a beacon in the darkness, each one a distant sun in its own right. Suspended in this void, we take in the grandeur of the scene. Nearby, a cluster of stars glitters like a handful of diamonds tossed upon black velvet. Farther away, the combined glow of billions of distant suns blends into a pale, milky band arcing across the sky. This hazy river of light is the collective glow of our home galaxy, seen from within. The Milky Way. Long ago, stargazers imagined it as milk spilled across the heavens, giving our galaxy its name. We now know it for what it truly is, an immense, disc-shaped congregation of stars. In the heart of that band, subtle patches of darkness mark enormous clouds of interstellar dust, momentarily obscuring the distant starlight. Yet even these dark veils add to the beauty of the vista, silhouetting the brightness beyond. Here in the depths of space, the stars no longer twinkle as they do when seen through Earth's unsteady atmosphere. In this perfect cosmic stillness, their light is steady and pure, arriving after journeys of many years, or even millennia through the vastness of the galaxy. Some stars around us burn with a fierce blue-white light, intense and young. Others glow softly golden, like gentle lanterns in the dark. Still more are dim and red, cooler and old, quietly shining with the last embers of their long lives. Scattered among them are double stars and triplets, multiple stars bound together by gravity, twirling in slow celestial dances around their common centre. We drift onwards, and new vistas open up. We pass through regions where stars are sparsely scattered, solitary beacons separated by tremendous distances. Then, gradually, we approach areas more crowded, where stars cluster closer together. In one such region, hundreds of stars gather in a loose family known as an open cluster. They were born together from the same cloud of gas and dust and remain loosely bound, like siblings who have not yet strayed far from their childhood home. The Pleiades, the seven sisters that adorn Earth's night sky, is one such cluster of youthful stars travelling together. These stellar siblings illuminate each other's skies, each star's light mingling with its neighbours. For any planets that might circle them, the night sky would be filled with many brilliant suns instead of one. Moving beyond the cluster, we find calm once more in a quieter stretch of space. Here the stars are older, placed in their orbits around the galactic centre billions of years ago. Over eons, they have drifted far from their birthplaces, spreading out around the galaxy. Each star carries on a slow pilgrimage around the centre of the Milky Way, a single orbit taking tens or even hundreds of millions of years to complete. Our own sun, situated in these outer galactic suburbs, takes roughly 200 million years to make one circuit around the galaxy, a period sometimes called a cosmic year. These timescales are almost impossible to fathom, yet out here among the stars, time stretches and slows in a grander rhythm. Above and below us, the galactic plane stretches flat and broad. Most stars crowd in this common plane, like fish swimming in the same layer of a vast ocean. But if we lift our gaze above this thin disk of light, we begin to sense the true shape of our galaxy. Far off in the distance, arching over the starry horizon, a subtle curvature becomes apparent. The Milky Way is revealed as a colossal spiral galaxy, tens of thousands of light years across. It may contain several 100 billion stars in total, an almost countless multitude. Two great spiral arms and several shorter arm segments coil around a bright central hub like a giant pinwheel. In our mind's eye, we rise farther out, watching the great wheel of stars from above. The spiral arms are faint and ethereal, with bright knots where clusters of young stars and glowing nebulae mark ongoing creation. Between the arms lie darker lanes, ribbons of dust that dim the light behind them. The central region of the galaxy swells into a luminous, rounded bulge at its core, shining like a bustling city at night.
Within that galactic core, stars are packed more closely together than anywhere else in the Milky Way. If we were to drift through those central regions, night would never truly be dark. So many stars would surround us that even in what we'd call night, space would hold a perpetual pearly glow. Out here, on the spiral arm where we journey now, nights are darker and lonelier, lit by only the far-off fires of neighbours scattered across light years. It is humbling to realise that we are still within just one galaxy, one island of stars, and already we see more suns than we could ever count in a lifetime. And beyond this single galaxy, countless others await, each a vast ocean of stars in its own right, scattered through the universe. For now, we remain among the stars of our Milky Way. In this great ocean of stars, patterns begin to shift and dissolve as our perspective changes. From Earth, humans once traced familiar constellations in the sky, connecting the brightest dots into figures and myths. But as we wander in 3 dimensions, those flat patterns distort and rearrange. The hunter Orion, who once stood proud in the winter sky, no longer looks the same from our new angle in space. One bright star, Betelgeuse, the red giant that marked Orion's shoulder, now lies far closer to us than the rest of the constellation, causing Orion's figure to lose its shape. What appeared to be a tight-knit pattern from Earth is revealed to be a chance alignment of stars scattered across different depths of space, each star following its own journey around the galactic center. The ancient pictures fade away, and we are left with the stars as they truly are, free and unbound by the lines our imaginations once imposed on them. The deeper we venture, the more profound the darkness between stars becomes. In some stretches of our journey, when no bright star lies nearby, we find ourselves enveloped in nearly perfect blackness. The nearest sun might be several light years away, its glow only a weak lantern glimmering faintly from afar. In those lonely reaches, one truly feels the immensity and solitude of space. The silence is almost palpable, and time itself seems to pause in this quiet void. Darkness and silence reign nearly absolute, broken only by the fragile light of distant stars shimmering at the edge of perception. Yet even in this apparent emptiness, we are not truly alone. The space between stars is not a complete void, but rather a very thin sea of its own, filled with the faint presence of cosmic material, wisps of hydrogen gas, microscopic grains of dust, and ghostly traces of other elements drift here in the interstellar medium. Invisible to our eyes in the darkness, these sparse ingredients are the seeds of future stars and worlds. Over immense timescales, these stray atoms and dust motes gather, drawn slowly together by the gentle pull of gravity. A tenuous cloud may take millions of years
to grow dense enough to be noticed. But given time, even the thinnest broth of matter in space can coalesce into something more substantial. As we voyage through the silent gulf, we notice a delicate change ahead, a soft glow, like a distant cloud reflecting starlight, begins to appear against the blackness. It is not the sharp pinpoint of a star, but a diffuse, hazy luminosity that gently brightens as we draw nearer. We are approaching one of those places where the interstellar medium, the gas and dust adrift between the stars, has gathered and ignited into visible form. What was once an invisible haze has become a great, luminous nebula hanging in space, its filaments of gas faintly glowing. This is a place of creation amid the emptiness, a celestial nursery where new stars are being born. The soft radiance ahead intensifies, shimmering in hues of pale rose and silver blue as we come closer. We begin to discern the shape of this stellar nursery. Vast billowing clouds of gas and dust, tens of light years across, lit from within by the fires of newborn stars. Dark patches and intricate tendrils of obscuring dust wind through the nebula, like cosmic brushstrokes across a glowing canvas. We drift at the threshold of this enchanted cloud, feeling the subtle pressure of starlight and the gentle presence of cosmic dust around us. With quiet wonder, we prepare to venture inside this nebula, into this cosmic nursery, to witness the emergence of new suns. Our journey carries us onward, seamlessly into the heart of creation. We glide quietly across the threshold of the glowing nebula, leaving the emptiness of open space behind. All around us, a soft, coloured radiance suffuses the void. We have entered the heart of a stellar nursery, a vast cloud of gas and dust where new stars are born. The light here is gentle but pervasive, a rosy luminescence from excited hydrogen gas mingled with an eerie blue haze where starlight scatters off tiny dust grains. Silhouetted against the luminous backdrop are towering pillars and ridges of denser dark material, like mountains and valleys in a ghostly landscape. Within these obscuring clouds, the first stages of starbirth are underway, hidden from direct view. Deeper inside the nebula, the glow intensifies. We approach a central cavity carved out of the gas, a hollow bubble where the newly formed stars themselves reside. A cluster of newborn suns shines here, their combined brilliance illuminating the surrounding nebula from within. These young stars are hot and blue-white, pouring out fierce radiation and stellar winds. In the few million years since they ignited, their energy has pushed away the nearby gas, hollowing this cavity and sculpting the fantastical shapes that adorn the nebula's inner walls. The scene is both tranquil and dynamic, tranquil in its silent, ethereal beauty, yet dynamic in that it captures cosmic creation in progress. Around us, the nebula is alive with structure. Long, sinuous filaments of glowing gas stretch like tendrils through the cloud. Dense knots and globules of darkness pepper the luminous background, the birth cocoons of protostars that have yet to reveal themselves. In one direction, a column of gas and dust towers, several light years high, its tip bathed in the soft glow from the cluster's light. This pillar's surface is slowly evaporating under the stellar glare, but inside its tip, sheltered from that harsh radiation, a new star is taking shape. It's a scene reminiscent of the famous Pillars of Creation in the Eagle Nebula, cosmic spires where infant stars nestle within. Here, too, the interplay of light and shadow marks where gravity is gathering the cloud into new suns. We drift toward one of these dense, dark clumps protruding from the nebula's brighter regions. Within this cool, opaque globule, gravity has been at work for countless millennia, drawing matter inward. The process may have been sparked long ago by the shockwave of a distant supernova or the pressure from the winds of earlier stars, disturbances that compressed the gas and set it collapsing. Now, deep inside, a protostar is growing. Though we cannot see it with our eyes through the dusty veil, we can imagine the scene. A contracting knot of gas, growing hotter and denser at its core. As it shrinks, it spins faster and flattens the surrounding material into a wide disk swirling around the protostar. Within that disk, gas and dust are beginning to stick together as well, forming the seeds of future planets. Jets of hot gas stream outward from the protostar's poles, piercing through the cloud. These twin jets, narrow and beam-like, carry away excess energy and angular momentum, helping the young star to continue its collapse. The jets burst out of the globule's surface, announcing the protostar's presence with faint, ghostly beams that mingle with the nebula's glow. Time in this nursery flows in epochs far beyond human scales. Over tens of thousands of years, the protostar at the core of this cocoon will grow ever hotter and denser. Eventually, its central temperature and pressure will soar to the critical point where hydrogen atoms begin to fuse into helium. When that moment comes, a true star is born. The protostar becomes a main sequence star, and its steady starlight will at last emerge. The newborn star's radiation and stellar wind will blow away the remnants of its birth shroud, clearing the opaque cocoon that once hid it. We imagine the darkness peeling back, revealing a brilliant young sun that was hidden there all along. All throughout this nebula, similar dramas are unfolding. Dozens or hundreds of nascent stars are in various stages of formation. Some, the most massive and quickest to develop, have already ignited and now dominate the nebula's illumination. Others are still gathering mass quietly in their cradles, not yet visible in the light we see. In a nearby portion of the cloud, we see a tiny cluster of stars that have just emerged from their natal dust. Their light, though much fainter than the central clusters, creates a small bubble of cleared space around them. They appear as a group of pale blue-white lanterns shining through a gauzy curtain, heralding the next generation of stars joining the cosmic tapestry. The environment in this stellar nursery is nothing like the emptiness of interstellar space outside. The airless void here is laced with the richness of creation. If we could stretch out our hand, though we cannot, as we are ethereal observers, we would still feel nothing. This cloud is far too rarefied to register as a breeze, but our eyes can perceive its beauty, and our minds can trace its influence. The gas here is predominantly hydrogen, the prime element of the cosmos, tinged with other elements formed in previous generations of stars: oxygen, carbon, nitrogen, cast into space long ago by supernovae, and now recycled into new suns and worlds. In this way, each stellar nursery is a bridge between cosmic generations, forging new lights from the ashes of the old. As we gently navigate through the nebula's luminous expanse, we pass near a particularly radiant patch where several newborn stars cluster together. Surrounding each of these young suns is a thin, dim halo, a protoplanetary disk seen nearly edge-on. In silhouette against the glowing gas, these disks appear as little dark rings or ovals encircling their parent stars. Within those spinning disks, dust and gas are gathering into clumps that will one day become planets, moons, asteroids, and comets. In some disks, gaps and rings have already formed as nascent planets sweep up material along their orbits. Though no life yet exists in this nascent stellar system, the ingredients and conditions that could one day give rise to life are assembling here, right now. It's a quiet promise, held within the glow of the nebula, that not only stars, but entire new worlds will emerge from these clouds of creation. Every so often, a subtle ripple in the nebula reminds us that this is an evolving, changing environment. Perhaps a massive star in the cluster has brightened suddenly or unleashed a stronger pulse of wind, or, more dramatically, one of the most massive newborn stars at the nebula's core might live out its short life quickly and explode as a supernova, even while its sibling stars are still forming. Such an explosion would flood the nebula with a burst of energy, briefly outshining all other stars, and send a shockwave rushing through the cloud. That shock could compress other parts of the nebula, triggering yet another round of star formation, even as the original nebula begins to disperse. In this way, the death of one star can ignite the birth of many others, one final act of creation as a star's life ends. For now, in our nebula, we see no such cataclysm yet, only the gentle stirrings of winds and the ever-present light of the young suns. But eventually, over millions of years, events like these will shape the destiny of this cloud.
Nothing in this nebula is static. With each passing million-year heartbeat of cosmic time, the stellar nursery changes. The bright young stars at the center will continue to blow the nebula apart from within.
The once dense pillars and globules will gradually erode under the onslaught of starlight, shrinking and dissipating. Newborn stars that were once hidden will step out of their dusty wombs and join the visible cluster. The colours of the nebula may shift as different elements become excited, or as the gas thins out. And after perhaps tens of millions of years, the nebula will have given birth to all the stars it can, and the remaining gas will be largely scattered. What will remain is a loose cluster of young stars, shining on their own against the backdrop of the galaxy, no longer swaddled in the glowing nursery that formed them. We take a last, lingering look at the stellar nursery around us. It is a sight of sublime beauty, a celestial garden where countless twinkles of infant stars are surrounded by petal-like swirls of nebular light. The very air, if one can call it that, seems to glow with creative energy. Slowly, we begin to move onward, rising gently out of the nebula's bright core. Behind us, the great cloud of gas and dust stretches out, an immense blossom in the darkness of space, cradling hundreds of young stars. Ahead of us, beyond the edges of the nebula, lie the open reaches of the galaxy once more. As we leave the fading glow of the cosmic nursery, we carry with us the knowledge that within it, new suns have taken their first breaths of stellar life. They will burn now for ages, each one embarking on a long journey from youth to maturity. Our journey too continues, following these stars out of their nursery and into the broader expanse of the galaxy, as we prepare to witness the next chapter in the lives of the stars. We drift away from the stellar nursery, carrying with us the light of a young star that has only recently emerged from its birth cloud. Out in the open galaxy once more, the nebula's glow fades into the distance, and our surroundings return to the deep darkness dotted with distant starlight. The young star we accompany now shines steadily, no longer a newborn, but a stable adolescent on the cosmic timescale. It has entered the longest phase of its existence, the long, steady adulthood of a star, known as the main sequence. In this phase, hydrogen in the star's core fuses into helium, releasing energy that has been lighting and warming the star's surrounding space since it left its nursery. Our star burns with a gentle brilliance, a balanced beacon of energy. Gravity pulls its mass inward, trying to make the star collapse, but the outward pressure of the hot gas and ongoing fusion reactions pushes back. These two forces, gravity squeezing in, energy pushing out, find an equilibrium, and the star remains stable, neither shrinking nor swelling. It will maintain this peaceful balance for many millions or billions of years to come, depending on how much fuel it has and how quickly it uses it. Around us, we sense the calm and constancy of this star's midlife. Its light is unwavering, each day much like the last, over immense stretches of time. In the vicinity of the star, any planets or worlds basking in its glow would enjoy a steady, reliable sun overhead for eons. Not all stars enjoy such lengthy periods of calm, however. In the universe, stars come in a vast range of sizes and masses, and a star's mass is the single most important factor in determining how its life will unfold. Our current star, much like our Sun, is of moderate mass, a type of star that lives for on the order of 10 billion years. But if we were to seek out a smaller star, we would find a very different story. Imagine a star much smaller and cooler than the Sun, a red dwarf, only a fraction of the Sun's mass. Such a star glows dimly with a red-orange light, like a quietly smouldering coal. Its fusion reactions proceed slowly and steadily. The star's light is faint, but it will continue to shine far longer than larger stars. These red dwarfs sip their fuel conservatively. Some may burn for hundreds of billions or even trillions of years, far outliving any other kind of star. In the current age of the universe, around 13.8 billion years since the Big Bang, not a single red dwarf has yet exhausted its fuel. None have had time to die. They are the slow burners, the quietly enduring stars that will be the last beacons of light in the very distant future of the cosmos. On the other end of the spectrum are the giants, the stars born with many times the mass of our Sun. Let us turn our attention to one such massive star. We find it shining a brilliant bluish white, many thousands of times brighter than the Sun. Its mass might be 20 times that of our Sun, and its core is a furious cauldron where nuclear fusion proceeds at a frantic rate. This star pours energy into space with intense luminosity, but that prodigious energy output comes at a steep cost. The star is burning through its nuclear fuel extremely quickly. While a star like our Sun may shine for billions of years, this massive blue star will exhaust its core fuel in only a few million years. A mere blink of an eye in cosmic terms. In its short lifetime, it will blaze hot and bright, dominating its region of space, perhaps ionizing nearby clouds with its ultraviolet light. Yet, inevitably, it will face an early death, as we shall see. Between these extremes, the diminutive red dwarfs and the massive blue giants, lie stars like the one we travel alongside now, and countless others of intermediate mass. For such a medium star, let's continue thinking of our Sun as an example. Life is comparatively uneventful for a very long time, but even this gentle existence must eventually come to an end. After billions of years of steadily fusing hydrogen into helium, the supply of hydrogen in the star's core will begin to dwindle. Our star has been spending its nuclear fuel slowly, building up helium ash in its core. Eventually, perhaps 5 or 6 billion years from now, in the case of a Sun-like star, the core's hydrogen will be nearly gone. When that happens, the delicate balance that maintained the star begins to tip. The core, now composed mostly of helium, starts to contract under gravity since it no longer has the outward pressure from hydrogen fusion to support it fully. As the core contracts, it heats up even more, and this intense heat causes the surrounding shell of still hydrogen-rich material around the core to ignite in fusion. Hydrogen begins fusing in this shell outside the core, pumping new energy into the outer layers of the star.
The result is dramatic. The star's outer layers begin to expand and puff outward. The star grows in size, turning into what we call a red giant. Its surface cools as it expands, so the star, once white-yellow, now takes on a reddish hue, but it is enormously larger and more luminous than before. Its light spread over a vastly greater area. If our sun undergoes this transformation, as it will swell to engulf the orbits of Mercury and Venus, and possibly even reach the vicinity of Earth's orbit, rendering our home world uninhabitable long before that point. But in this far future scenario, no humans will likely remain to witness it. If life from Earth is to survive, it would have needed to find new homes among the stars, long before the sun's red giant phase arrives. We find ourselves now in the vicinity of a red giant star, observing firsthand what this phase looks like. The star's atmosphere is extended and tenuous. If we drift into its outer envelope, we might find it surprisingly thin, not the solid surface one imagines when picturing a star. It is more like a very diffuse, hot wind, growing denser as we move inward. The star's core, buried deep inside, has become incredibly hot enough that eventually it will trigger the fusion of helium into heavier elements like carbon and oxygen. For a time, helium fusion in the core provides a new source of energy, and the star settles somewhat, possibly contracting a bit after its initial overexpansion. But this is a temporary reprieve. In stars of roughly sun-like mass, the helium fuel will in turn run out after a relatively brief period, tens of millions of years, a short time compared to the earlier billions of stable years. The core will contract again, perhaps pulsating the star's output in a series of thermal pulses that gently shake the star's outer layers. In these final stages, the outer layers of the red giant become increasingly unstable and loosely bound. Pulsations and strong stellar winds begin to carry away those outer layers into space. What was once the star's surface drifts off, forming an expanding shell of gas around the now contracting core. If we step back, we can see this shell as a beautiful, glowing cloud, a planetary nebula, so named not because it has anything to do with planets, but because through a telescope, these objects sometimes appear round and planet-like in shape. Here, before our eyes, a planetary nebula blossoms, the dying star's exposed core, now blazing extremely hot in ultraviolet light, floods the expanding gas shell and makes it fluoresce in rich colours, delicate blues and greens from oxygen, reddish hues from hydrogen and nitrogen. The nebula might take on a ring-like shape or a faintly spherical shell. Some planetary nebulas look like floating cosmic jellyfish or ghostly irises in the dark.
One particularly evocative example is the Ring Nebula in Lyra, a wreath of gas lit from within by a tiny central star. Another is the Helix Nebula, which uncannily resembles a giant eye in the sky. As we gaze upon our red giant shedding its substance, we witness the creation of just such a nebula. It is a quiet and poignant final act rather than a violent explosion. It gracefully casts off its outer layers, seeding the surrounding space with elements and materials that were forged in its interior over its lifetime.
At the center of the expanding planetary nebula, the star's core remains. No longer able to sustain fusion, it has become a white dwarf, an extremely hot, dense ember of a star, about the size of Earth, but containing roughly half the mass of the Sun. This white dwarf is initially blindingly bright in ultraviolet, though small in size. Over billions of years, it will cool and fade, eventually becoming a dim, cold, black dwarf. Though the universe is not yet old enough for any white dwarfs to have cooled that far. For now, the white dwarf shines intensely, illuminating the departing veil of its former self. If we draw nearer, we would see that gravity on the white dwarf's surface is incredibly strong. The material in a white dwarf is compressed to such a degree that a single teaspoon of its matter would weigh tons upon tons. Yet, aside from perhaps a faint bluish glow and perhaps some flickers, if the white dwarf cools and crystallizes, it is a quiet remnant. This is the fate that awaits our sun and stars of similar mass, to end their days as a beautiful planetary nebula surrounding a slowly cooling white dwarf, a cosmic memory of the star that once was. But what of the more massive stars, those titanic blue-white suns that burn through their fuel so rapidly? Their end is far more violent and spectacular. When a very massive star, say 8 or 10 or more times the mass of the Sun, exhausts its core fuel, the story is somewhat different. Such a star will also swell into a supergiant. Many become red supergiants, much like Betelgeuse, the bright star that marks Orion's shoulder, which even now is nearing the end of its life. In the supergiant's core, successive fusion processes occur in rapid stages. Hydrogen fuses to helium, helium to carbon and oxygen. Then in the most massive, carbon to neon, oxygen, silicon, and so on, creating layered shells within the star like an onion. Each stage burns faster than the last. So while helium might last 1,000,000 years, oxygen might burn only for a year or less in the core of a giant star. Finally, iron is formed in the core, and iron fusion absorbs energy rather than releases it, so the star can gain no further reprieve. At that moment, the balance that held up the star
is lost catastrophically. The iron core, no longer supported by fusion pressure, collapses in on itself in a fraction of a second. The core implodes until it is stopped by the incredibly stiff resistance of nuclear forces, and then it rebounds. What follows is one of the most extreme events in the universe, a supernova explosion. The rebound of the core, combined with a flood of energetic particles called neutrinos, released from the core collapse, blows the star apart from the inside. The infalling outer layers slam into the rebounding core and are explosively ejected outward. For a brief time, perhaps a few weeks, the star's dying explosion can outshine an entire galaxy. We cannot fully comprehend the power of such an event. The brightness of 100 billion suns concentrated in one titanic detonation. If we were positioned at a safe distance, the supernova would appear as a sudden ferocious increase in the star's brightness. A star that once perhaps was just one of many pinpoints in the sky would become a beacon so bright it could cast shadows at night on any nearby worlds. Then, over weeks and months, it would slowly fade, but not to nothing. Where once a star stood, there is now an expanding cloud of stellar debris. This is the final fate of the most massive stars. Total self-destruction, leaving behind glorious remnants like the Crab Nebula, the aftermath of a supernova observed by earthly skywatchers in 1054 AD, or the Veil Nebula, the remains of an even older supernova. These filaments and curtains of gas, colouring the cosmos with the heavy elements forged in the star's final moments, will eventually mix with other clouds in the galaxy. In time, they may become part of new stars, new planets, new life. What about the core of the star that exploded? In many cases, it survives in a transformed state. For a massive star, not quite at the top tier, perhaps up to around 20 or 30 solar masses initially, the collapsed core is compressed into an incredibly dense ball of neutrons, a neutron star. This neutron star contains perhaps 1.4 times the mass of our Sun, but packed into a sphere only about 20 kilometers across. It is a piece of matter so dense that a single cubic centimeter, the size of a sugar cube, would outweigh a mountain. The neutron star may spin rapidly. If the original star was rotating, the collapse spins it up like a twirling ice skater pulling in her arms. A neutron star can rotate dozens or even hundreds of times per second. As it spins, it often emits beams of electromagnetic radiation from its magnetic poles. If those beams sweep past our point of view, we would perceive pulses of light or radio waves, and so we call such spinning neutron stars pulsars. Out here, far from the chaos of the supernova, we might detect a gentle blinking or ticking of a pulsar in the aftermath, like the fading heartbeat of the massive star that was. One of the first pulsars discovered in fact, lies at the heart of the Crab Nebula, blinking 30 times a second amidst the expanding wreckage of its parent star.
For the most massive stars of all, however, even the remnant core is too heavy to form a neutron star. When a core well above the neutron star limit collapses, nothing in nature can halt the collapse. The core continues to shrink, the gravity growing without bound, until it crushes itself into a singularity, a point of infinite density, at least according to classical physics. Surrounding that point is a region of space where gravity is so strong that not even light can escape. Thus, a black hole is born. This is the ultimate end state of the very biggest stars. An object so dense, so gravitationally intense, that it punches a hole in the fabric of space-time itself. The departing layers of the star roar outward in the supernova, but the core vanishes from view, replaced by a gravitational trap from which no light can return. All that might betray its presence is the motion of nearby gas or stars responding to its pull, or perhaps later, a disk of infalling material glowing as it swirls into the dark. In the death of stars, we see both the end and the beginning entwined. The heavy elements, scattered by red giants and supernovae, will become the seeds of new suns and planets. Every atom of carbon in our bodies, every molecule of oxygen we breathe, every bit of calcium in our bones and iron in our blood was forged in a star that lived and died long before the Earth formed. The cosmos recycles its matter through generation after generation of stars. In that sense, stars never truly vanish without a trace. They leave behind the building blocks for new creations. We ourselves are living testaments to that cycle, as we are literally made of star stuff.
Our journey has now shown us the entire glorious life cycle of stars, from their gentle birth in cosmic nurseries, through their long stable lives shining upon any worlds around them, to their varied and dramatic ends. We have witnessed peaceful deaths that create ghostly planetary nebulae, and violent deaths that light up the galaxies as supernovae. And now, one profound mystery beckons us onward. We stand on the edge of an all-consuming darkness, the aftermath of the mightiest stellar death. Ahead lies the region where a massive star's core collapsed to form a black hole, a literal hole in the universe's fabric, an abyss from which not even light can escape. Drawn by curiosity and wonder, we prepare to venture into that silent void, to explore the mysteries of the black hole, the dark abyss left in the wake of a star's passing.
We venture now into one of the most mysterious and extreme realms of the universe. Ahead of us, where once a massive star shone, there is now only a profound darkness. This is the aftermath of the star's collapse, a black hole, the abyss left behind when a giant star's core is crushed beyond all measure. At first, from a distance, we see nothing at all.
The black hole itself emits no light. It is an invisible well in space-time. But as we draw nearer, subtle clues announce its presence. The star field behind it appears strangely distorted. Starlight passing near the black hole is bent into rings and arcs. It's as if we are looking at the night sky through a warped glass. For an object that cannot be seen directly, the black hole makes its mark by the way it warps the space around it. We cautiously approach the black hole, remaining at a safe distance. Now we notice a delicate glow encircling the region of darkness. Not the black hole itself, but a halo of light from material that has wandered too close. In this particular case, the black hole is not entirely starving. It has captured a trickle of gas from its surroundings, perhaps siphoned slowly from a nearby star. That gas forms a swirling accretion disk, spiraling inward and heating up as it does so. The disk glows faintly with a soft, bluish-white light as the gas becomes hot, maybe even emitting X-rays, though our eyes cannot see those. The glow illuminates the silhouette of the black hole, outlining a dark sphere at the center of the whirlpool of gas. This dark sphere is the event horizon, the boundary of the black hole, often called the point of no return. Anything that crosses this invisible threshold, be it gas, dust, or even a beam of light, is forever lost to the outside universe. It is truly an abyss. Once you step into it, there is no coming back out. Hovering here, just outside the event horizon, we feel no material sensations. There is no air, no warmth from the black hole. Indeed, it is cold in the sense of emitted heat. But we experience a profound sense of finality emanating from that dark boundary. Time and space themselves are stretched and twisted by the black hole's gravity. If we could watch an object drifting closer to the horizon, we would see it appear to slow down and fade, as if time for it has nearly frozen as it approaches that ultimate edge. To the infalling object itself, time would seem normal, and it would pass through the horizon without fanfare. But to us, observing from outside, it never quite appears to cross the threshold. Instead, it dims and redshifts, its light shifted to longer and longer wavelengths until it vanishes from view. In this way, the event horizon acts like a one-way membrane. Things can go in, but information does not come back out. It's a silent veil drawn over whatever falls beyond. The gravity near the black hole is incredibly intense. Were we to stray too close, the difference in gravitational pull between our nearer side and farther side would stretch us grotesquely, a process scientists grimly nickname spaghettification. Fortunately, we remain at a respectful distance, where the tidal forces are not immediately harmful. Still, the power of the black hole's gravity commands respect. We watch as the gas in the accretion disk whirls around at a significant fraction of the speed of light. Near the inner edge of the disk, just outside the event horizon, orbiting material can circle multiple times in the blink of an eye. friction and magnetic fields in the disk heat the gas to extreme temperatures, causing it to glow. Occasionally, turbulence in the disk may cause some of the infalling gas to be diverted into a pair of narrow jets that shoot out above and below the disk, carrying energy away into space. Such jets, if present, would appear as faint, straight beams extending from the poles of the black hole's rotation axis. Though in our current scene, the accretion disk is weak and the jets are but a suggestion. Mostly, what we have is a quiet black hole with a gently glowing disk, hidden in the darkness of space, except for the subtle lensing of background starlight and the soft radiance of its captured matter. We take a moment to contemplate what lies beneath that event horizon. It is a realm we cannot truly see or visit and report back. According to Einstein's theory, at the center of the black hole, all the mass is crushed into a singularity, a point of infinite density and zero volume, where the known laws of physics break down. Space and time as we understand them cease to have meaning there. Perhaps quantum effects, or as yet unknown physics, resolve this paradox. But for now, it remains an enigma. What we do know is that nothing from inside the event horizon can communicate with the outside universe. The interior of the black hole is cut off, like a sealed tomb for the star that died to create it. To fall in would be to surrender oneself to the unknown. There is a strange peace here, hovering near the black hole. Despite the ferocious gravity, in our imaginary vantage point, we feel only the quietude of space. The disk's soft light bathes one side of our view, while the other side is filled with the undisturbed stars of the galaxy. The black hole itself, utterly dark, offers a kind of visual rest, a patch of pure night, free of starlight. If one didn't know what it was, one might mistake it for just an oddly starless spot in the cosmos. Only the gentle bending of light and the ring-like distortions around its edges give it away as something extraordinary. We recall that this black hole was once the heart of a massive star, a star that lived perhaps millions of years, shone brilliantly, and then perished in a supernova, leaving this dark remnant. In that violent death, the star dispersed its outer layers, enriching the galaxy with heavy elements. But its core imploded to form this black hole, locking away mass equivalent to perhaps 10 suns inside an invisibly small region. The dual legacy of the star's end is both creation of new elements and nebulae, and this creation of an absence, a hole in space where the star's core used to be. Black holes come in different sizes too. The one we are visiting now might be a few times or a dozen times the mass of the Sun, a common sort created by supernovae. But there are black holes far more massive, and we need not go far to find one. We turn our journey toward the center of our Milky Way galaxy, where we earlier marveled at the dense cluster of stars. Diving back into that crowded central region, we recall the bright swarm of suns we imagined, orbiting like bees around an unseen hive. Now we know what resides at the center of their dance. Deep in the Milky Way's core lurks a supermassive black hole, a behemoth with the mass of about 4 million suns. This gravitational giant has likely been there for billions of years, gradually feeding on the occasional star or gas cloud that wandered too near, growing heavier over time. It currently sits quiet for the most part, a sleeping giant, but its presence is betrayed by the motions of stars around it, stars that race around the invisible center at breakneck speeds. Indeed, astronomers on Earth have observed these very stars, with names like S2, swinging around an unseen focus, completing loops in just over a decade. An astonishing feat, given the distances involved. Only a supermassive black hole could cause such rapid orbits. We approach this central colossus, careful to keep beyond the realm of its significant gravity. Compared to the stellar mass black hole we visited, this one is much larger in scale. Its event horizon is about as wide as the orbit of Mercury around the Sun. Paradoxically, that means the tidal forces at its boundary are gentler. An object could actually cross the event horizon of this supermassive black hole without immediate destruction, since the gradient of gravity over a human-sized object at the horizon would be small. But that's small comfort, for crossing that horizon would still mean never coming out. Around this black hole, there is far less glowing gas than around the smaller one. The galactic center's environment has been swept relatively clean. Occasionally, this supermassive black hole does snack on a bit of material, and when it does, it can produce flares or X-ray bursts. Most of the time, though, it is effectively dark, like a silent, heavy heart at the center of the Milky Way. If we could view this black hole with extraordinary resolution, we might see something akin to the famous image that astronomers captured of another galaxy's central black hole in M87, a ring of light framing a darkness. In 2019, and again in 2022, humanity witnessed the first direct visual evidence of such black holes. A glowing donut of light created by hot gas around the event horizon, with the black hole's shadow in the middle. The one in our Milky Way was imaged as a fuzzy ring, just as expected. It is awe-inspiring to realize that what we are imagining now, floating here in our mind's eye, has been indirectly seen by telescopes across Earth working in unison. Surrounding the supermassive black hole is the dense star cluster of the galactic nucleus. Millions of stars crowd the volume near the center. Their collective light, along with the soft glow of wisps of gas, faintly illuminates our scene, so it is not completely black here. But as we drift outward from the immediate vicinity of the black hole, the star density decreases to the more typical conditions of the galaxy's inner bulge. We take one last look back at the center, the stars circling an unseen darkness, a formidable mass holding court in the galactic core. It's humbling to know that nearly every large galaxy has a similar secret at its heart, a supermassive black hole anchoring the dynamic dance of its stars. Having glimpsed the abyss up close, we now gently withdraw from the galactic center. Our perspective widens. The details of individual stars blur into the overall glow of the Milky Way's core. We leave behind the realm of black holes and extreme gravity, carrying with us a reverent respect for these enigmatic objects. They are destroyers, and yet also caretakers in a sense, shepherding stars in their orbits. They quietly influence the growth of galaxies and serve as cosmic engines in the most active galactic nuclei when feeding. But from our current vantage, our galaxy's central black hole is a slumbering giant, content with the stars that swirl around it. As we drift farther out, the full grandeur of the Milky Way comes into view once more. We have journeyed from the bright arms of the galaxy, through stellar nurseries and the lives and deaths of stars, and into the darkest depths of a black hole's domain. Now it is time to lift our gaze and see the broader tapestry in which all these stories unfold. Beyond the individual stars and their remnants lies the structure that binds them together, the galaxy itself, and beyond that, the vast multitude of galaxies that populate the cosmos. With the central abyss at our backs, we accelerate outward, as if riding a shaft of starlight, until the swirling panorama of the entire Milky Way lies before us. The time has come to explore the galactic realms, the island universes of stars, nebulae, and dark matter that form the large-scale landscape of the universe. Our journey continues, seamlessly, into these immense and beautiful realms of the galaxies. From our vantage point in space, we continue to pull back, gaining distance and perspective. The Milky Way, our home galaxy, which from within was an endless ocean of stars, now reveals its grand design as we drift further out. We see it face on in all its majesty, a vast spiral disk floating in the cosmic dark. The spiral arms sweep outwards from a bright central bulge, curling like luminous ribbons adorned with countless stars. Clusters of young blue stars and pinkish nebulae trace the spiral pattern, marking where new generations of stars light up the arms. Between the arms, darker lanes of interstellar dust give the galaxy texture and depth. Our Milky Way spans about 100,000 light years from edge to edge, an almost unfathomable expanse, yet just one galaxy among many. Glimmering faintly around the disk, we notice a spherical halo of old stars and globular clusters, and within that halo, invisible to our eyes, but exerting its influence, lies a vast sphere of dark matter that holds the galaxy together. This invisible mass outweighs the visible stars by a considerable amount, acting as a cosmic glue that prevents the Milky Way's rotation from flinging stars off into space. As we watch this great spiral slowly turning, it completes one revolution only once every few 100 million years. Our gaze drifts to its companions. The Milky Way is not alone in this galactic realm. Orbiting around it are several smaller galaxies. Among them, we see the large and small Magellanic Clouds, two irregularly shaped dwarf galaxies that resemble faint glowing patches when seen from Earth's southern hemisphere. Here, from our panoramic viewpoint, they appear as little sidekicks to the Milky Way, their shapes distorted by our galaxy's gravity. There are dozens of other dwarf galaxies in our vicinity, many too faint to see without zooming in. The Milky Way's extended family. Together with the Milky Way, these form part of what we call the local group of galaxies. Turning our eyes outward, we find the great spiral of the Andromeda Galaxy, the Milky Way's nearest major galactic neighbour. Andromeda is a spiral galaxy, somewhat larger than our own, about 2.5 million light-years away. In the darkness of an earthly sky, Andromeda appears as a dim, smudgy patch. But from here, we can appreciate it in detail. Its spiral arms and bright core are reminiscent of our Milky Way, shining with the light of 1 trillion stars. Andromeda and the Milky Way are moving inexorably toward each other. In several billion years, these two giant spirals will merge in a slow, cosmic dance, their stars intermingling to form a single, perhaps elliptical, galaxy. But there is nothing to fear in this predicted collision. Despite the word collision, the vast distances between individual stars mean that very few stars, if any, will actually hit one another. Instead, the two galaxies will pass through each other, their mutual gravity pulling and stretching them into tidal streams. Over a long period, they will likely settle into a new, larger galaxy. The once graceful spiral patterns disrupted and reformed into something new. Future skies, seen by whatever distant descendants or other beings might exist then, will witness a dramatically altered night view. But the process will be stately and slow from the perspective of a human lifetime, happening over billions of years. For now, in our time, the Milky Way and Andromeda reign as the dominant members of the local group, a gentle cluster of a few dozen galaxies bound together by gravity. The local group itself is a part of an even grander structure. It lies on the outskirts of the Virgo cluster, a massive cluster of galaxies. Shifting our perspective wider, we see that tens of millions of light-years away, the Virgo cluster gathers together over 1,000 galaxies in a gigantic swarm. Spirals and ellipticals, dwarfs and irregulars, all held in a gravitational embrace. At the cluster's centre reside giant, elliptical galaxies. One of them, known as M87, is a Goliath, many times the mass of the Milky Way, and it harbours a black hole, billions of times the mass of the Sun. The very black hole, famously imaged by Earth's telescopes as a dark shadow in a ring of light. The galaxies in the Virgo cluster orbit their common centre, occasionally interacting and merging. Within the cluster, hot gas fills the space between galaxies, emitting X-rays, which we cannot see with our eyes, but instruments reveal it. This gas, along with substantial dark matter, provides the gravitational glue for the cluster. Our local group and the nearby Virgo cluster are themselves part of a still larger entity, often called the Laniakea supercluster, an immense collection of groups and clusters of galaxies, including Virgo and many others, spanning hundreds of millions of light years. We find that galaxies are not uniformly distributed throughout the universe. They form patterns on gigantic scales, drawing our view even farther out. The arrangement of galaxies begins to resemble a cosmic tapestry or web. Galaxies gather in clusters. Clusters connect in chains and filaments, and between these filaments lie enormous voids, vast regions with far fewer galaxies, sometimes tens of millions of light years across, of near emptiness. This is the cosmic web, the large-scale structure of the cosmos. It is as if the universe has a foamy texture. Imagine soap bubbles in a sink. The galaxies lie along the thin walls of the bubbles, and the interiors of the bubbles are the voids. The analogy is not perfect, but it gives a sense of how matter is spread out on the grandest scales. We drift along one of these great cosmic filaments now, our view moving unimaginably fast, for we must traverse tens of millions of light years in moments in our thought journey. Beneath us, so to speak, is a string of galaxy clusters connected by thinner chains of galaxies, like pearls on a string. Each point of light in these clusters is not a star, as it was when we roamed within the Milky Way, but an entire galaxy glowing with billions of stars. The mind struggles to grasp it. Each tiny smudge is a galaxy akin to our Milky Way, which itself contained hundreds of billions of stars. And we see dozens, hundreds, thousands of such smudges, peppering the darkness. In some regions, they are densely packed, cluster cores where ellipticals congregate. In others, sparse. Between the filaments, we peer into a void where for many millions of light years there may be hardly any galaxies at all, perhaps a few lone dwarfs drifting in the darkness. Invisible to our eyes, but ever present, a scaffold of dark matter underlies this cosmic web. It was the dark matter, that mysterious, invisible form of matter that neither emits nor absorbs light, that first formed the backbone of the cosmic web through gravity, and normal matter, gas and stars, followed, gathering where the dark matter density was highest. Though we cannot see dark matter, we see its effects. It makes galaxies orbit faster than they would with visible mass alone. It bends light subtly from distant objects, a phenomenon called gravitational lensing, and it gives the cosmic web its structure. In a way, dark matter is the silent architect of the galaxies. As we wander this vast web, we appreciate that what we see, the galaxies, clusters, and light, is only a small fraction of what is there. Yet even just the luminous matter, the stars and glowing gas, paints an awe-inspiring picture. Now, let us think of scale and numbers. Our Milky Way, one galaxy of hundreds of billions of stars, is one of perhaps a few trillion galaxies in the observable universe. This observable cosmos is a sphere around us, or any observer, about 93 billion light-years in diameter. beyond which light has not had time to reach us since the beginning of the universe. Within that enormous volume, galaxies range from tiny dwarfs with a few million stars to giants with trillions. The sheer number of stars in the universe is mind-bending, roughly estimated at a 1 followed by 22 zeros, 10 22 stars, or more. These numbers boggle the mind. But here and now, as we glide through intergalactic space, we do not feel overwhelmed by numbers. Instead, we feel the majesty of the scene, galaxies scattered like glittering jewels on the black velvet of space, stretching out as far as the eye can see in every direction. Each galaxy is separated from its neighbours by immense gulfs of mostly empty space, on average a few million light years apart, though in clusters they draw much closer. In the darkness between galaxies, it is nearly perfect night. If we were truly here in person, far removed from any galaxy's light, we would see only the faint collective glow of the nearest galaxies. Tiny swirls and ovals, some luminous, some barely perceptible. We would be in intergalactic space, where typically only a few atoms of hydrogen drift per cubic meter. It is a realm of incredible solitude. Yet, looking back towards our own galaxy, we see the Milky Way as a flattened starry disk, shining among its peers. One can imagine that from this far vantage, an entire galaxy might evoke the same feeling of wonder as a starry night sky does when seen from a dark earth, but magnified, knowing each sparkling point is a galaxy entire. Consider for a moment one tiny patch of sky, perhaps the size of a grain of sand held at arm's length. When the Hubble Space Telescope pointed at such an apparently empty sliver of sky in the 1990s, what it found astonished the world. The image, known as the Hubble Deep Field, revealed that this little dark patch was teeming with galaxies upon galaxies, nearly 3,000 of them in that narrow cone of vision, some so distant that their light had been travelling for over 12 billion years to reach us. They were seen as they were in the deep past, when the universe itself was young. This told us two profound things. First, that the universe is densely populated with galaxies in all directions. And second, that by looking far enough, we are also looking back in time. Thus, our exploration of galactic realms is not only a journey through space, but also a journey through time. The farther a galaxy lies, the earlier in cosmic history we are seeing it. Some of the faint red smudges in the Hubble Deep Field are galaxies from the infant universe, mere hundreds of millions of years after the first stars formed, just starting to build their structures. As we float in this intergalactic expanse, we reflect on how connected everything is, yet how vast the separations are. Galaxies occasionally interact, trading gas, merging, or tugging on each other via gravity across millions of light years. But for the most part, each galaxy is an island universe, as the early astronomers aptly called them. They shine with their own billions of stars, harbour their own retinues of planets, perhaps even their own life forms, and are separated from other galaxies by tremendous distances. And yet, taken together, they form the fabric of the cosmos on its grandest scales. They outline the cosmic web and participate in the overall expansion of the universe. Yes, the universe is expanding. One of the remarkable discoveries of the 20th century was that distant galaxies are, almost all, rushing away from us, and from each other, generally speaking. The space between galaxies is stretching. The farther a galaxy is, the faster it appears to recede. This doesn't mean we are at the center of the universe. Rather, every observer anywhere would see the same general expansion. It's like dots on a balloon surface moving apart as the balloon inflates. Each dot sees the others receding. Here in our intergalactic viewpoint, we can almost sense this expansion. If we could speed up time fantastically, we would see clusters of galaxies moving apart, the voids growing larger, the filaments becoming more distant from one another. Over billions of years to come, galaxies that are not gravitationally bound together will separate more and more. Distant galaxies will slip beyond our horizon of visibility as their light gets redshifted to oblivion by the ever-accelerating expansion, driven, as we now theorize, by a mysterious force called dark energy. But those changes are far, far beyond the scope of our current journey. Still, it's humbling to know that the universe itself is dynamic on the largest scales, carrying galaxies along like driftwood on a vast, stretching ocean. For now, let us revel in the cosmic panorama as it exists in this epoch. Before us is the Virgo cluster with its swarm of galaxies. To one side, the local group with our Milky Way and Andromeda. Further out, we see hint of the Coma cluster, rich with thousands of galaxies. And all around, countless others, each a spark in the darkness. We find beauty in the diversity. Some galaxies are grand design spirals with well-defined arms, like the graceful Whirlpool galaxy, silently spinning with its companion galaxy tugging at one arm. Some are irregular and chaotic, perhaps distorted by a past encounter. Some are giant ellipticals, huge balls of reddish stars, the fossil remains of many past mergers, their youthful blue stars long gone, only ancient stars remaining. There are ring galaxies like cosmic ripples, shell galaxies with layered tidal debris from recent mergers, and needle-thin edge-on galaxies where we see their thin disk silhouetted against their own starry glow. The universe is as creative as it is immense, crafting myriad forms for these galactic systems. Amidst this cosmic multitude, one cannot help but wonder about the possibility of life and consciousness in the universe. When looking at 100 billion galaxies, each with billions of stars and untold worlds, it seems almost inevitable that we are not entirely alone. Perhaps in some distant galaxy, another being is looking out at their sky, seeing the Milky Way as a tiny speck of light and wondering if someone is there. Perhaps life is rare, Or perhaps it burgeons in countless corners. We do not yet know. But the sheer scale of the galactic realms makes the question all the more profound. The cosmos feels vast, possibly teeming with possibilities. Yet due to the immense distances, each civilization, if others exist, could be like isolated voyagers, waving across gulfs of space with signals that take ages to traverse. Our journey in space has now carried us from the familiar, our home planet and star, out through the Milky Way, into the realm of stars and their life cycles, into the darkest depths of black holes, and now to the grandest scales of all, the tapestry of galaxies and clusters. We have effectively traversed a significant portion of the observable universe in our imagination. Floating here at this godlike vantage, the universe presents itself as a single entity, a glittering network of galaxies strewn across the void. It's a peaceful sight in many ways. Despite the unimaginable energies and distances involved, from here, the cosmos looks calm, almost static, like a frozen fireworks display. Only when we think of timescales of millions or billions of years do we remember that it all evolves. Galaxies collide and merge. New stars are born while old ones die. Clusters pull together. Space expands. With a gentle sense of wonder, we begin to conclude this segment of our voyage. We have seen so much. The gentle sparkling ocean of stars in our galaxy, the nurseries where stars take shape, the full span of a star's life and dramatic death, the enigmatic black holes that punctuate the cosmos, and the staggering panorama of galaxies forming the cosmic web. Yet, there remain deeper questions and mysteries. How did this cosmic web come to be? What set the galaxies in motion? What is the ultimate fate of the universe? And what role do we, conscious beings on a tiny planet around one star, play in all of this vastness? These questions beckon us onward. Though we have travelled far, in many ways, we are still near the beginning of understanding. Our journey does not end here. As we gaze into the distance, beyond the furthest galaxies we can see, we sense the faint whisper of something even more ancient, the afterglow of the Big Bang itself, a pervasive background light that is the echo of creation. We feel time stretching behind us to nearly 14 billion years ago, when the universe was hot, dense, and filled with a brilliant primordial light. That story, the story of how the universe began and evolved to form the galactic wonders we've witnessed, lies ahead of us to explore. And with it, perhaps, the ultimate destiny of the cosmos, and questions of meaning and existence linger just beyond the horizon of our current journey. With hearts full of wonder, we let the image of the cosmic web imprint itself in our minds. Slowly, we pivot ourselves away from the broad overview and start to imagine moving forward once again in time. The galaxies continue to glow softly in the void, the great drama of the cosmos unfolding on scales both immense and minute. There is a serene music in their arrangement, a silent cosmic symphony. We take one last panoramic look. countless galaxies, like a sea of lanterns extending to the darkness beyond. And then, carrying the awe of this vision with us, we prepare to venture into the next chapter of our exploration. The marvels of space have more to show us, from the dawn of the universe to the possibilities of worlds and life yet undiscovered. Our cosmic journey, gently and inevitably, continues onward into the deeper mysteries of existence, with the assurance that wherever we go, the wonder of the universe will accompany us, lighting the way.
In the silent depths of space, a faint whisper lingers from an almost unimaginable past. Long ago, before any star had ever shone, the universe was filled with a brilliant light. That light has faded with time, stretched and cooled as the cosmos expanded. Yet it has never disappeared. It remains all around us, an almost imperceptible glow that fills the dark sky with a quiet echo. This is the afterglow of creation, the cosmic memory of the moment when everything began. Nearly 14 billion years have passed since the universe's birth, and the fierce brightness of that dawn has gentled into a soft murmur. Wherever we look with sensitive instruments, we detect this faint background glow. It is a uniform, gentle warmth coming from every direction, bathing the universe in remnant light. In these subtle patterns of ancient radiation, we hear echoes of the primordial fireball that once was. Scientists call it the cosmic microwave background, a whisper from the dawn of time, carrying a message about the universe's first moments. In those first moments, the universe was nothing like we know now. It was an ocean of energy, hot and dense beyond comprehension. Space itself was smaller than a single grain of sand, yet it contained everything that would ever exist. Then, in a fraction of a second, it began to unfurl. Time and space blossomed outward, carrying matter and light with them. There was no sound. Sound cannot travel where there is no air. Only pure light and searing heat filled the young cosmos. It was the birth of all things, a silent explosion of creation. As the universe expanded and cooled, that blinding light gradually lost its intensity. What was once the brilliant flash of creation became a faint, diffuse glow. The cosmos grew dark for a time. For hundreds of millions of years after that initial burst, there were not yet any stars, only vast, tranquil clouds of hydrogen gas drifting through an expanding darkness. The universe was quiet and unlit, but not empty. Within those primordial clouds lay the seeds of future galaxies, hidden in the gloom and gently drawn together by gravity's subtle tug. Within those deep, dark clouds, gravity worked slowly and silently. Over eons, gas gathered like mist condensing into dew. Where some clouds grew dense enough, the first stars were born. At first one, then many, igniting like embers scattered across the cosmic night. These first stars were colossal and blue hot, and they lived brief, brilliant lives. In their hearts, they forged new elements: carbon and oxygen, silicon and iron, heavy atoms
that the early universe had never known. Then, in titanic supernova explosions, the first stars spent their last fuel and blew themselves apart, casting those new elements far and wide. It was a cosmic sowing. The ashes of those early stars mixed into space, seeding the raw material for later generations of stars and planets. It was as if the universe, having been born in light, exhaled and filled itself with the ingredients for life. Every star that twinkles in the night sky today, including our own sun, can trace its lineage back to those first brilliant suns. And every atom in our bodies, the calcium in our bones, the iron in our blood, was forged in the crucible of some ancient star. We are, quite literally, made of stardust, assembled from the remnants of long-ago suns. In this way, each of us carries an echo of creation within us. The same fire that ignited the primordial cosmos burns quietly in our cells. The story of the beginning lives on, inscribed in our very beings and in the light that surrounds us. When we gaze up at the night sky, we are looking across immense distances and deep time. The light from the stars is like a message sent long ago that is only now reaching our eyes. Some of the starlight we see tonight left its source when humans did not yet exist, perhaps even when Earth itself was young. The farther out into space we peer, the further back in time we travel. Powerful telescopes act as time machines, capturing faint glimmers of the early universe. In a tiny patch of seemingly empty sky, the Hubble Space Telescope once revealed thousands of distant galaxies, each a swath of light that had been journeying toward us for billions of years. And now, a new generation of observatories, like the James Webb Space Telescope, is peering even deeper, unveiling galaxies that formed when the cosmos was in its infancy. These distant lights are direct echoes of creation, snapshots of how things looked long ago. Through them, we witness the universe's youth, the first galaxies assembling, the first starlight breaking the cosmic darkness. Even the great silence of space isn't truly silent. Beyond the reach of our ears, the universe holds a faint hum, a lingering vibration from its earliest days. It is the cosmic microwave background itself, this all-sky glow of ancient light. When scientists first detected this signal in the 1960s, they were puzzled. No matter where they pointed their antenna, a persistent noise appeared. At first they thought it might be a flaw or interference. One famous story even blamed pigeons nesting in the antenna for the confusion. But soon it became clear that the noise was coming from nowhere on Earth at all. It was everywhere, because it was the afterglow of the Big Bang, still faintly illuminating space. Sensing this hum was like discovering that the air around us carries the quiet music of creation, a sound so soft that only our most sensitive instruments can perceive it. What do these cosmic echoes tell us? They speak of a young universe that was nearly uniform, almost the same in all directions, yet not perfectly so. There were tiny imperfections, like small ripples on a smooth sea. Over time, those slight ripples grew. Gravity drew matter into the denser pockets, and gradually the first galaxies and clusters took shape. In the subtle variations of the cosmic background's glow, scientists have found the imprint of those early ripples. It is a baby picture of the cosmos, a blueprint etched in faint radiation for everything that would one day emerge. Stars and galaxies, clusters, and ultimately, us. The echoes of creation contained the seeds of all the structure we see in the universe today. To us, living on a small world billions of years later, these signals are exceedingly faint and cold. The cosmic microwave background is only a few degrees above absolute zero, just a whisper of warmth left from that incandescent beginning. Yet it is everywhere, a gentle reminder that the cosmos shares a common origin. No matter where one stands in the universe, if you could tune your senses to this ancient light, you would find the same soft glow, the same subtle whisper from the same dawn. It ties together all of space like an invisible thread, connecting the farthest galaxy to the smallest flower on Earth, to that first singular moment when it all began. All around us, other relics of that beginning quietly persist. There are tiny neutrinos, nearly massless particles forged in the hot furnace of the young universe, that still drift through space by the trillions, passing even now through your body without a trace. And perhaps there are faint gravitational waves, ripples in the fabric of space and time, still coursing through the cosmos from those first instants. They would be extraordinarily subtle, beyond our current ability to detect, but they would represent another kind of echo, the universe remembering its own birth through the gentle trembling of space itself. From the first moments to the present day, the universe has been expanding and changing, but it has never forgotten its beginning. We, as beings made from the dust and light of the cosmos, are part of that ongoing story. In our very atoms, and in the light that warms our days, the past remains alive. The sunlight that falls on your face today was born in nuclear reactions deep within the sun. Reactions made possible by elements created in ancient stars, which in turn were formed from the primordial matter of the Big Bang. It's a continuous thread, stretching from the first dawn of creation to each living moment we experience. Realizing this can be deeply comforting and wondrous. The universe is not a cold, distant stranger. It is our long-standing home. We emerged from it. We are made of its star-born elements, and we are sustained every moment by its energy. In that sense, each of us is a child of the cosmos, connected across time to the first light and the first atoms. If you listen with your imagination, you might sense those connections. A quiet resonance linking your existence to the very beginning of everything. It is a reminder that even when we feel small or alone, we are part of something vast, ancient, and beautiful. Yet, for all we have learned about that first light and the echoes of creation, much remains mysterious. The universe keeps its secrets. Layers of reality we are only just beginning to perceive. The bright galaxies and stars we see are only one portion of the cosmic story. There is much more that we cannot see, which has been there since the beginning, silently shaping the cosmos. As our journey continues,
We venture into these hidden realms of existence, the unseen threads that bind the cosmic tapestry together, quietly guiding the evolution of galaxies and ultimately ourselves. Beneath the surface of the visible cosmos lies this invisible framework, an underlying reality that we can only glimpse through its influence. As we look deeper into space and measure the motions of stars and galaxies, we find clues that something unseen is orchestrating everything we see. Galaxies, those immense cities of stars, spin in a way that defies what our eyes alone can account for. The outer stars of a spiral galaxy whirl around the center so fast that by ordinary gravity they should be flung off into the void. Yet they remain, bound to the galaxy as if by an invisible tether. It is as though each galaxy is held in a gentle, unseen embrace that keeps it from falling apart. This mysterious glue is what we call dark matter. We cannot see it or touch it. It emits no light, no heat, no signal that our telescopes can directly detect. And yet, its gravitational pull betrays its presence. Dark matter surrounds galaxies in vast, spherical halos, like a transparent cocoon of gravity. It threads between galaxies too, forming an immense cosmic web that stretches across space. Along these hidden filaments, ordinary matter, gas, dust, and stars collects and clumps together, forming galaxies in the densest spots, much as dew gathers on a spider's web. We see the glittering dewdrops, the galaxies, but not the web itself, the immense scaffold holding the cosmos together is invisible. Imagine drifting far above a galaxy and watching it rotate slowly over millions of years. You would notice that beyond the glowing spiral of stars and nebulae, the galaxy's gravitational influence extends much farther, cradling its outlying stars in a vast unseen halo. That halo of dark matter is far more massive than all the stars within it. When we weigh the universe, adding up all the matter we can see, every star, every cloud, every planet, it turns out to be only a small fraction of the total mass that must be there. The rest, the majority, is this dark matter, quietly holding the cosmos together. In a very real sense, most of the universe's matter is invisible to us, known only by the gentle tug it exerts on the things we can see. What could dark matter be? That question remains one of the greatest scientific mysteries. We know it must be something fundamentally different from the atoms that make up the familiar world around us. It might be a kind of particle that very rarely interacts with normal matter, passing through entire planets and people as easily as a beam of light through a clear window. Every second, billions of these mysterious particles could be streaming through your body, and you would never know. They leave no trace, like a silent wind blowing through an empty night. Physicists have built elaborate experiments deep underground, hoping to catch the faintest whisper of a collision between dark matter and ordinary matter. So far, dark matter has remained elusive. Its true nature is hidden behind a cosmic veil, teasing us
with its gravitational effects, but refusing to show itself directly, while dark matter works as an invisible cosmic glue. Another even stranger phenomenon is at work on an even grander scale. If dark matter pulls, this other force pushes. We call it dark energy, though that name is just a placeholder for something we have yet to understand. In the late 20th century, astronomers expected that the expansion of the universe, set in motion by the Big Bang, would gradually slow down over time, pulled back by the gravity of all the matter. To their astonishment, they discovered the opposite. The expansion is speeding up. The universe is not only expanding, but expanding faster and faster as the ages pass, as if driven by a repulsive force embedded in the very fabric of space. Dark energy appears to be a property of space itself, a smooth, persistent energy that fills even the emptiest void and drives it to expand. Imagine the universe as an enormous, silent balloon, and dark energy as a constant, gentle breath, inflating it more and more with each passing epoch. Galaxies are carried along by this expansion like dust motes on the surface of a swelling balloon. Over immense spans of time, the distances between clusters of galaxies grow ever wider. The vast darkness between them stretches out like taffy. If this continues unchecked, the cosmos of the far future will be a much lonelier place, with galaxies so far apart that each one is marooned in darkness, nearly invisible to all the others.
Today, dark energy is thought to make up roughly 70% of the total content of the cosmos. Dark matter accounts for about 25%. The ordinary matter that we directly observe, all the stars and nebulae, planets and people, amounts to less than 5%. In other words, everything we've ever seen, felt, or touched is just the tip of a cosmic iceberg. The vast majority of existence is invisible and mysterious. It's humbling to realize how little of the universe's substance we truly understand. We live in a cosmos dominated by dark ingredients, and we are only beginning to fathom what they are. Still, even if we cannot see these dark components directly, we have begun to map their effects. By observing how galaxies cluster on the largest scales, we see the influence of dark matter shaping the cosmic landscape. It has sculpted a delicate lattice of structure, patterns of filaments and voids, like the veins in a leaf or the foam on a gentle wave, on scales so vast that light itself takes billions of years to traverse them. Where dark matter is densest, galaxies have gathered into clusters and superclusters. In the enormous spaces between these filaments lie cosmic voids, nearly empty expanses where only the occasional galaxy drifts. The universe's large-scale structure is a reflection of that hidden scaffolding of dark matter, laid down in the universe's infancy and drawn out over eons by gravity. Meanwhile, dark energy works behind the scenes, subtle yet relentless. We do not feel it in our everyday lives, but across billions of light years, its effect becomes dramatic. If we could watch the universe in fast forward, we would see distant galaxies racing away faster and faster as space itself stretches between them. This mysterious acceleration raises profound questions about the fate of everything.
Will the expansion continue to speed up forever, driving galaxies so far apart that each becomes an island unto itself? Will the stars eventually burn out with no new light to replace them, as the gaps between galaxies widen into an eternal night? For now, we don't know. What we do know is that the discovery of dark energy has reminded us that the cosmos still holds deep surprises. Even in what seems like empty space, there is power and mystery. Not everything hidden in the universe is as diffuse as dark matter, or as all-pervasive as dark energy. Some cosmic secrets are compact, with gravity so strong that they trap even light itself. Consider a black hole, a place where matter has been crushed into such density that the fabric of space and time is pulled into a deep well. Within a certain boundary around this mass, gravity is so intense that nothing, not even a beam of light, can escape. That boundary is called the event horizon, effectively a one-way door in the universe. Anything that crosses that threshold vanishes from our observable realm, falling into an abyss from which no information returns. The object becomes truly black, a perfect darkness against the background of space, revealed only by its profound effect on its surroundings. For a long time, black holes were hypothetical creatures, lurking in the mathematics of Einstein's theory of gravity. The idea of a star so massive and collapsed that it punches a hole in space-time sounded like science fiction. But over the decades, evidence for black holes steadily mounted. In the heart of our own Milky Way, astronomers observed stars whipping around an apparently empty patch of space at astonishing speeds. These stars were orbiting something massive, yet no light came from that spot, not a single glimmer. The only plausible explanation was a supermassive black hole containing the mass of millions of suns anchored at the galaxy's center. Now we think nearly every large galaxy has a colossal black hole in its core, like a heavy anchor at the heart of a whirlpool, helping to keep the stellar city bound together. Black holes exist on smaller scales too. When a giant star reaches the end of its life, it may collapse under its own gravity, triggering a supernova explosion and leaving behind a dense core. If that core is massive enough, a few times heavier than our Sun, gravity overwhelms all other forces and crushes it into a black hole only a few miles across. Countless such stellar mass black holes, the remnants of once bright stars, drift unseen through galaxies. They are usually quiet and invisible unless they interact with nearby matter. If a black hole passes through a cloud of gas or tugs on a companion star, it can collect a swirling disk of gas around itself. As that gas spirals inward, it heats up and shines, often in X-rays, just before it plunges into the darkness. In this way, a black hole that was once hidden can announce its presence with a burst of high-energy light, only to fade back into obscurity after its feast is done. Despite their fearsome reputation, black holes are an integral part of the cosmic ecosystem. They help regulate the growth of galaxies by swallowing matter and sometimes blasting out energy that can trigger or halt the birth of new stars. In a sense, they act like cosmic gardeners, pruning and shaping their galaxies over time, and our ability to study them has grown dramatically. In 2019, a global team of scientists linked telescopes across our planet to form one giant eye, and they captured the first direct image of a black hole's immediate vicinity. What they saw was a glowing ring of hot gas silhouetting a circular darkness, the shadow of a supermassive black hole in a distant galaxy. It was a striking confirmation that something truly lightless lurked at the center, warping space itself. There are other ways we've learned to sense the invisible too. In recent years, we constructed instruments so sensitive that they can feel the subtle tremble of space itself. When massive objects like black holes or neutron stars collide, they send out ripples through space-time, much like a stone dropped in a pond sends ripples across the water. These ripples are gravitational waves. In 2015, detectors on Earth heard the universe speak in this new language for the first time. They sensed the quivering signal from two black holes that spiraled together and merged more than 1 billion years ago. The signal was incredibly tiny, changing distances by a fraction of the width of an atom. Yet we detected it, a faint chirp from the fabric of space. Since then, we've listened to several more cosmic collisions. Black holes merging in darkness, neutron stars crashing and spraying heavy elements into space. These events were utterly invisible to traditional telescopes, yet they rang out clearly in gravitational waves, allowing us to witness violent dramas that unfolded in complete blackness. By listening to the universe in this new way, we have opened a window onto the dark side of the cosmos, catching sights and sounds that were once beyond our reach. All of these achievements highlight how far we've come in illuminating the darkness. Piece by piece, we are uncovering the hidden universe, shining a light on what was once pure mystery. We've learned that reality is far more expansive and strange than the slice of it we perceive with our eyes. And with each discovery of the unseen, our picture of the cosmos becomes richer and more awe-inspiring. Yet, for all we have uncovered, the vast majority of the universe's essence remains unknown. We find ourselves living in a universe where most of the matter and energy are mysterious, where fundamental questions, what is dark matter? What is dark energy? Still linger unanswered. This realization is humbling, but it also fills us with wonder. We are part of a cosmos that is not a simple, empty stage, but a complex tapestry woven of both light and darkness, the known and the unknown. In the midst of this cosmic tapestry of unseen forces and hidden wonders, there is another marvel to consider, one that, in its own way, is as profound as black holes or dark energy. Out of this vast universe, governed by physical laws and composed of stars and atoms, there emerged something that can ponder it all. Amid the swirling galaxies and dark matter and the silent expansion of space, there is life. On at least one small planet, the universe has opened its eyes and found itself looking back. As we reflect on the invisible forces shaping the cosmos, we turn now to perhaps the most poignant mystery of all. In all the expanse of space, are we truly alone? Or is the universe home to countless other beings living under alien suns? Our own existence is a product of this universe's curious capacity to assemble complexity. Here on Earth, over billions of years, simple atoms bonded into molecules, molecules built cells, and cells evolved into conscious creatures that can wonder and feel. We know, beyond any doubt, that life is possible because we are here. But we cannot help but ask, is life an incredibly rare accident, or is it a common thread woven through the cosmos? Is the spark that flickered into being on Earth also kindled on myriad worlds across the galaxy? Life as we know it is intimately connected to the cosmos. The carbon in our cells, the water we drink, the energy we consume, all were forged or influenced by cosmic processes. Our planet formed from the same disks of dust and gas that formed the Sun and all the other stars. Comets and asteroids bombarded the early Earth, likely delivering water and organic molecules. And perhaps in a warm little pond, or around a deep-sea volcanic vent, or somewhere in the young ocean, those molecules assembled into self-replicating patterns, and life began. Once it began, it evolved, diversifying and exploring every niche of the environment, from simple single-celled organisms to the vast complexity of a rainforest or a human brain. Life flourished on our world. Is Earth unique in this regard? It's natural to think of our home as special. And indeed, the combination of factors that make our biosphere stable and rich is intricate. But when we peer out into the galaxy, we find that many of the ingredients for life are not unique at all. Liquid water, which is essential to life as we understand it, is abundant in various forms out there, hidden beneath the icy shells of moons, glistening in the rings of Saturn as grains of ice, or vaporizing from comets that swing close to the sun. Organic molecules, the building blocks of biology, are found in interstellar clouds and on meteorites. Planets of all sizes orbit distant stars, and among them we have discovered many that might have the conditions to host life. Rocky Earth-like worlds at the right distance from their suns for water to remain liquid. The recipe that produced life here could, in principle, produce life elsewhere. Life has proven to be astonishingly hardy and creative on Earth. We find microbes thriving in hot springs that would scald us, in the crushing darkness at the bottom of the ocean, inside Antarctic ice, and even in toxic, acidic lakes. Some bacteria endure radiation that would sterilize any other creature, and tiny animals called tardigrades can survive the vacuum of space. If life can take root in such extremes here, might it not also endure in the harsh environments of other worlds? Perhaps beneath the frozen crust of Jupiter's moon Europa, an ocean of water sloshes, warmed by tidal forces. Could something swim in its dark depths? On Saturn's moon, Enceladus, geysers of water spurt into space from another subsurface sea. Could there be simple organisms stirring in those alien waters? Mars, with its dry red deserts, once had rivers and lakes. We have found tantalizing hints that microbial life could have existed there long ago, and perhaps still survives in isolated pockets underground. Even Titan, Saturn's largest moon, with its liquid methane lakes and smoggy skies, makes us wonder if life could use a different chemistry and flourish in conditions very different from Earth's. Beyond our solar system, the discoveries come at a breathtaking pace. Only a few decades ago, we had no proof that other stars had planets. Now we know of thousands of exoplanets orbiting distant suns. They come in an astonishing variety, some scorched by their star's heat, some icy and dim, some water-rich, some gassy giants larger than Jupiter, and many roughly the size of Earth. Some of these planets lie in what we call the habitable zone, the just right range of distance where a planet similar to Earth could have mild temperatures and liquid water on its surface. We've detected potential signs of atmospheres around some, and even hints of water or clouds. We can imagine rain falling on far-off worlds, winds blowing in alien skies, perhaps oceans lapping against shores under a different sun. On some of those worlds, could there be life swimming in the seas or crawling on the land, watching their own sky with curiosity? It's a thought that fills the heart with wonder. We have yet to find direct evidence of life elsewhere. The universe has not yielded that secret easily, at least not yet. We listen for radio signals from other civilizations, so far hearing only an inviting silence. We scrutinize the light from distant planets for telltale signs, like oxygen or other gases, that might indicate life stirring below. So far, these remain tantalizing possibilities, awaiting confirmation. But consider this. Our searches have only just begun. We've only been truly looking for a few decades, and our technology is just now reaching the level where it might detect the faint signatures of biology on a planet dozens of light years away. Every year, we learn to listen and look with greater sensitivity. It could be that tomorrow, or next year, or decades from now, we'll pick up a whisper that can only be explained by the presence of life across the cosmic ocean. Sometimes the question is framed as the Fermi paradox. If intelligent life is common in the galaxy, why haven't we seen clear evidence of it? Some suggest that the distances are just too vast and communication too difficult. After all, our nearest star, besides the Sun, is over 4 light-years away, which is about 25 trillion miles. If an alien world around that star sent a signal when we first invented the radio, it would only just now be reaching us, and vice versa. The galaxy is huge, and signals weaken over distance. Civilizations might be rare or short-lived, separated by both space and time. It's possible that intelligent life arises only to dwindle or destroy itself before ever reaching out to the stars. Or perhaps the universe is teeming with life, but mostly microbial life, or simple creatures in the oceans of distant worlds. Life that does not build radio transmitters or powerful telescopes, but still thrives in its own way, quietly. We must also consider that if intelligent beings are out there, they might be very different from us, or choose not to communicate in ways we expect. They might even be watching us quietly, deciding to let us develop on our own, a thought both eerie and fascinating. For now, these ideas remain in the realm of speculation and imagination, stimulating our minds as we scan the sky for answers. Whether life is abundant or vanishingly rare, either answer is profound. If life is common,
then the universe is rich with our kin, creatures who, like us, play and struggle, and perhaps wonder about their place in it all. If we are rare, or even unique, then we carry an incredibly precious flame, a singular consciousness of the cosmos that it might not find elsewhere. In either case, our responsibility to cherish life, to protect and celebrate it, is immense. On our pale blue dot of a planet, life has transformed the surface and atmosphere. Green plants and algae fill the air with oxygen. Countless living organisms, from the tiniest bacteria to the great whales, are part of Earth's grand balanced system. If someone far away were observing Earth's spectrum of light, they would see hints of our life here. Perhaps the oxygen, the water vapor, maybe even the faint seasonal changes in our atmosphere. Earth sings out, subtly, that it is alive. One day, we might discern a similar living signature in the light of a distant planet, and know that we have neighbours in the great loneliness of space. For now, we continue to search and to listen. We send out our own signals, intentionally or not. Every television and radio broadcast, every radar ping has been leaking out into space for decades, an expanding bubble of human-made signals washing over nearby star systems. Perhaps one day, far in the future, someone light years away will catch a stray fragment of an old earthly broadcast, a snippet of a song, a bit of news, and know that somewhere in the depths of that darkness there was a civilization with music and stories. The thought of life beyond Earth stirs something deep within us. It forces us to imagine new possibilities, to stretch our minds. It also reflects back on us, showing us the unity of life on our own world. All humans, indeed all creatures on Earth, are relatives sharing one fragile sphere. From the vantage of space, as astronauts have often remarked, the boundaries we fight over, the divisions we cling to, fade away. We are left with a simple truth. We are together, alive at the same moment on a beautiful planet, surrounded by the cold and the dark. Together, we form a kind of family. Life, in the cosmic sense, is the rare, precious thing. Stars will shine, and planets will spin, with or without life. But a world with life is something special. It knows the universe in a way that a barren rock cannot. As one famous astronomer said, "We are a way for the cosmos to know itself." Through our eyes, the universe has seen its own grandeur. Through our instruments, it has begun to understand its age and its workings. And through our emotions, the universe can feel wonder, because we feel wonder, and we are not separate from the cosmos, but an expression of it. So here we stand, creatures of stardust and chemistry, pondering the stars. We have journeyed from understanding almost nothing about the universe to mapping it in detail. Yet we still yearn to know if others share this grand stage. The night sky above, spangled with stars, asks us questions in its silence. Who else is out there? What is our fate? How do we fit into the grand design of existence? Our curiosity drives us outward and onward. As we ask these questions, we find ourselves pushing against the boundaries of what we know. We contemplate not just life within this universe, but even possibilities beyond our universe. When we speak of the universe,
we usually mean all that we can observe, all of space and time as we understand it. But could it be that our universe is only one part of a far larger reality? It's a staggering idea, almost impossible to grasp fully. Yet modern cosmology has entertained the possibility that our universe might be just one of many. For a long time, the concept of multiple universes, a multiverse, was mostly the domain of philosophy and science fiction. But as scientists tried to understand the very beginning of our cosmos, some theories naturally led to the idea of other universes. One idea, for example, is called eternal inflation. It suggests that during the Big Bang, there was a moment of incredibly rapid expansion, inflation. In many models of inflation, while our patch of space-time stopped inflating and formed stars and galaxies, other regions might still be inflating, or might have inflated and stopped, each creating a bubble universe of its own. In this view, beyond the horizon of what we can see, there could be other big bangs popping off, other expanding bubbles of space-time, each disconnecting from the others, each becoming its own universe, with perhaps different properties and laws of physics. Our entire observable universe would be just one bubble in an endless foaming sea of universes. Another mind-bending idea comes from quantum physics and the notion of parallel worlds. The equations of quantum mechanics, which governs the microscopic realm, can be interpreted in such a way that every random event or decision point causes reality to branch into multiple outcomes, each outcome becoming the history of a new universe. If that interpretation, often called the many worlds interpretation, is true, then literally every possible history that can happen does happen, but in separate parallel universes that are constantly splitting off from one another. In one universe, you took a different path in life than in this one. In another, stars and galaxies formed differently. Maybe life evolved in a completely different way, or not at all. There are also theories about higher dimensions, in which whole other universes might exist, alongside ours, like pages in a book, or bubbles in a larger dimension. For instance, string theory, a speculative framework for physics, suggests there could be extra spatial dimensions beyond the familiar three, and our universe might be a membrane, brain, floating in a higher dimensional space. Other brains could be other universes, perhaps with different types of particles and forces. It's conceivable that occasionally these brains might collide or interact, perhaps even triggering big bangs. These concepts are highly theoretical. We don't have evidence for other universes. Indeed, by definition, if they are completely separate, getting evidence might be extraordinarily difficult or impossible. Yet scientists have proposed clever ways we might infer them. For example, maybe a neighbouring universe once brushed against ours in the distant past, leaving a subtle pattern in the cosmic microwave background. Or perhaps quantum calculations hint at their existence. So far, these remain tantalizing ideas. What these ideas do, at the very least, is expand our perspective of what everything might mean. It is already challenging to grasp the scale of our universe. Hundreds of billions of galaxies, each with billions of stars,
stretching out over 90 billion light-years visible to us, and perhaps much more beyond that which we cannot see. Now imagine many such universes, maybe an infinite number, each with their own vast expanses, some perhaps almost empty, some filled with stars and life, some governed by different physical constants where no familiar atoms can form. In some universes, there might be no light. In others, no time as we experience it. The possibilities boggle the mind. If we think of the multiverse, we might ask, what about life and consciousness in those other universes? Could some of them harbour beings who will never know about us, just as we may never know about them? Are there universes where life never arises, and others where it takes forms we cannot imagine? These questions layer wonder upon wonder. How does one find peace or meaning in such a colossal array of possibilities? Perhaps by recognizing that, whether or not there are other universes, the fact that our universe exists and has given rise to us is miracle enough to inspire awe. The multiverse idea, if true, suggests that reality has countless chapters, maybe an infinite library of stories. But we, here and now, are living out one unique story, the story of this universe. From the Big Bang to now, and we are a part of it. It may be that we will never have proof of any universe except our own. Or perhaps one day, in the far future, our descendants, or whatever life comes after us, will find a way to glean evidence of those other realms. Either outcome is mind-expanding. If ours is the only universe, it is an isolated jewel of existence, all the more precious. If there are others, then the scope of creation is so vast that it humbles any imagination. Standing here, on the threshold of the unknown, we feel the limits of our understanding, yet also the boundlessness of our curiosity. We may not be able to travel to other universes, but just contemplating them stretches our minds. It reminds us that there may always be more to reality than we can see, more beyond each horizon. Whenever we think we've reached the ultimate, the infinite, we can still wonder, might there be something beyond even that? This wonder drives science, philosophy, and imagination. Our journey has taken us from the birth of our universe, through the brilliance of stars and the mystery of the unseen, into the question of life, and onward to the possibility of innumerable universes beyond our own. It's a journey, both outward and inward, touching the grandest scales and the deepest questions of existence. Throughout this journey, one thread has woven consistently: wonder, a sense of awe at the beauty and mystery of it all. No matter how much we learn, the universe, and perhaps the multiverse, offers endless frontiers to explore. With each answer we obtain, new questions arise. This might seem frustrating to someone who yearns for a final, complete understanding, but there is a profound peace in accepting that we may never run out of things to discover, that the quest itself is endless and beautiful. It means the spirit of curiosity can live on forever, and that each generation, each being, can have the joy of discovery. We have travelled so far in our imagination. We began with the echoes of creation, the faint afterglow of the universe's birth. We moved through the cosmic dark, uncovering hidden forces that shape all we see.
We pondered life's emergence and the possibility of companions in the cosmos. We stretched our thoughts to realms beyond our universe. Now, as we gently return our focus to the here and now, we carry with us the treasures gathered along the way, the images, the insights, the feelings of connection and humility. Picture, for a moment, the night sky once more. Here on Earth, perhaps you stand under a clear night, the air cool and still. Above, the stars spread out in their countless numbers, silent but sparkling. The Milky Way arches overhead like a faint cloud of light. That band of the Milky Way is the combined glow of billions of distant stars in our home galaxy, so far away that their light blends into a river of pale luminosity. For as long as humans have existed, we have stood under that sky and felt small, felt curiosity, felt reverence. The same sky that awe-struck ancient farmers and sailors and poets is above us today. We share that experience with all who came before and with each other. Now we know so much more about what those points of light are, and yet the knowledge hasn't diminished their beauty. In many ways, it has deepened it. When you or I look at a star now, we can know that it might have planets of its own. We might imagine what that star looked like when it was young, or how it will eventually grow old. We might even consider that someone on a planet around that star could be looking back at our sun, wondering too. The scientific understanding adds layers to the wonder. It doesn't replace it. In our mind's eye, we can zoom out from our planet. See the Earth, a blue-white marble suspended in darkness, with the moon as a smaller companion. Our perspective widens. The sun is one star among the hundreds of billions in the Milky Way. Wider still, the Milky Way is one galaxy among perhaps 2 trillion in the observable universe. And beyond even that, there might be more universes. It's like a series of nesting dolls, or like standing between 2 mirrors and seeing reflections repeating endlessly. We seem so small in all of this, a single individual on a tiny planet in a vast cosmos. And yet, we matter, because the universe is aware of itself through us. In that sense, the universe is not entirely cold or empty. Part of it is alive and warm and thinking. As our journey through cosmic wonders comes to a close, we might ask, what have we gained? Perhaps a sense of perspective that can comfort us in our daily worries. Perhaps a feeling of connectedness to the universe, knowing that our bodies are made of ancient atoms that have circulated through stars. Perhaps a gentle reminder of how precious and rare life is, and how extraordinary it is to be conscious, even for a brief moment, in this ancient, enormous universe. We also gain a sense of humility. When we consider black holes and galaxies and the age of the universe, our personal troubles can feel a bit smaller. The cosmos has weathered exploding stars and colliding galaxies. It has seen planets form and planets melt. It has time spans that make our lifetimes look like the blink of an eye. This could be humbling in a dispiriting way, but it can also be liberating. It means that the pressure is off. We don't have to have all the answers or control everything. We are part of a much larger story, and that story will continue with or without us. But while we are here, we can watch, we can learn, we can appreciate, we can add our verse to the cosmic poem.
There is also something deeply human and hopeful in how we confront the vast unknown. We wonder, a child looking up for the first time, asking, "What are the stars?" is participating in the same grand tradition as the astronomers mapping the heavens. To wonder is to be alive, to have an active mind and a sense of awe. Our capacity for wonder may be one of the greatest gifts the universe has given us. It propels us to create art and science, to tell stories, to seek meaning. And wonder is not just for the young or the scientists. It's for everyone, at every moment. You can feel it by noticing the pattern of the stars, or the way Saturn's rings look through a small telescope, or simply the fact that gravity holds your feet to the ground while the Earth spins through space. Wonder can be found in the petals of a flower, shaped by eons of evolution, or in the eyes of a cat reflecting the starlight. The microcosm and the macrocosm, from quantum particles dancing to galaxies colliding, all inspire wonder when we truly pay attention. So, after journeying among galaxies and contemplating eternity, we come back home, filled with a quiet awe. We realize home is not just our city or country, not just our planet, but the entire universe. We belong here. We are at home in the cosmos. The elements in our body were forged in stars. The energy that fuels us comes from the sun. We are tied inexorably to everything else. This knowledge can bring a profound sense of peace, a feeling that no matter what happens in our individual lives, we are part of something enduring and magnificent. Now, let the vastness of what we've explored gently settle in your mind. Imagine all those distant galaxies, like tiny lanterns in a great dark sea, continuing their slow dance as they have for billions of years. Imagine the countless stars being born, shining, and eventually going out, like the rise and fall of breaths on a cosmic timescale. Picture the possible lives out there, on worlds we have yet to discover, perhaps gazing at their skies in wonder, just as we do. And picture the possibility that beyond the curtain of our universe, other universes lie quietly, perhaps with their own tales of creation and wonder, unreachable yet real. Underneath it all, feel the stillness of the night and the warmth of existence. The universe is vast, but it is also strangely comforting in its grandeur. We are cradled by physical laws that allow us to exist. We are nurtured by a planet that provides air and water. We are witnesses to a spectacle that has been ongoing since time began. Our voyage through these galactic wonders now comes to a gentle end. We have touched the edges of understanding and peered into the profound unknown. In doing so, perhaps we have also touched something within ourselves, a sense of peace, of belonging, and of endless curiosity. The marvels of space are not just out there, they are within us, in our thoughts and feelings, as we reflect on what we've learned. As you let these images and ideas drift through your mind, you can allow yourself to relax in the knowledge that the story continues. The universe will continue unfolding its mystery, and generations after us will look up
and ask their own questions, discovering new wonders. In a way, we are never really saying goodbye to these marvels. They will be there whenever we need inspiration or perspective, waiting quietly in the sky above or in the ideas of science and dreams. Feel the calm that comes from this grand perspective. The troubles of the day grow distant for a moment. You are part of a cosmic story, and that is a beautiful thing. In this quiet moment, under the eternal stars, your heart can swell with awe and then settle into tranquility. The cosmos is vast beyond measure, and yet here you are, a unique part of it, with the ability to understand and appreciate its majesty. Our journey ends not with a period, but with an ellipsis, a gentle continuation into the unknown. For now, we have travelled together through space and time in our thoughts, and we pause to rest, but the wonder remains, lighting a small eternal candle in our minds and hearts. As you close your eyes and breathe softly, remember that the same universe that sparkles above is the one that lives within you. Its atoms are your atoms, its laws your laws, its history your history. You are a child of galaxies, a friend to the stars. In that knowledge, find comfort. Let a sense of calm curiosity guide you into the night. Feel the embrace of the dark sky above, not as emptiness, but as a presence filled with meaning and stories and possibilities. We have journeyed far and seen so much, yet there is always more to wonder at. That wonder is a gentle companion that will never leave you. In the stillness, a thought emerges, soft as a whisper. The universe is vast, but it is not cold. It is home to us. The universe is mysterious, but it is not cruel. It invites us to explore. The universe is beyond our full grasp, but it is not beyond our appreciation. It rewards us with beauty at every turn. In this balance of knowing and not knowing, of striving and yielding, we find peace. And so, as the stars wheel above and the night deepens, we conclude this chapter of exploration. With a heart full of awe and a mind at ease, we return from the edge of the cosmos to the quiet of our own place and time. The echoes of creation, the hidden universe, the possibility of life beyond, the notion of other universes. All these marvels now reside within your thoughts, like precious jewels gathered on a long voyage. They will shine there, giving you perspective and gentle wonder whenever you need it. Thank you, Cosmos, for sharing your story with us. We end our journey with gratitude for the glorious spectacle of the heavens, for the ability to perceive it, and for the sense of connection it brings. Under the infinity of stars, we rest in humble amazement. The adventure of understanding continues, but for now we simply breathe in the cosmic night and feel its peace. In this moment, everything is as it should be. You are here, a part of it all, and that is a wondrous thing. The universe unfolds in vast, grand cycles, and life is one of its most exquisite blossoms. As we bid good night to the galaxies and turn inward to our own quiet world, we carry with us an everlasting gift, a feeling of eternal wonder at the marvellous tapestry of existence. May that feeling cradle you gently through the night and greet you with the sunrise, again and again, as long as the stars shine and beyond.